Once in a year, there is a special summons. The best Java event is here, and it's time for you to join in. This is no ordinary gathering. It's where everyone comes together for an amazing time. I'm excited to welcome each and every one of you. And now, without further ado, let's shout it out loud. Java is on. Hello everyone, and welcome to Java On Conference. My name is Roman. I'm glad to welcome all of you. I hope you like the beginning. ChatGPT a bit helped me with it, for sure. So we will have some topics about it, but still. So, Java On 2023 is here, finally. I hope you enjoy it. I hope you will enjoy it. I'm glad to see you all here. So I hope we'll fix all the technical problems which potentially can appear, very soon. So I will not be alone here today. So each of the days, there will be co-host with me. And today I would like to introduce my co-host, Evgeny Nikiforov. Evgeny, welcome to the stream. Hello.
Hello, Roma. My name is Evgeny. So nice to see all of you coming today to this amazing conference. Today we are going to have a lot of the great talks with amazing speakers, and we will talk about Java today, a lot about Java today. And I believe that everybody will gain so much interesting things here, and not only from the theoretical part, but also from the practical part. And if you have any questions, I would like to just give you some kind of the heads up to ask your questions to the speakers, and we will ask it in the online mode in the Q&A session. Basically in the end of every talk today.
Yeah, sure. We will talk about it even more, and we'll remind you about that. So to start, let me show you some small presentation for the opening. So I will ask our operator to share my screen. Here you can see Java On 2023 from 15th to 17th of November. Finally, it's here. So who brought this conference to you? It's three communities. It's MGC, JaCoV, and mini communities. We are really working hard since April, I would say, to deliver this conference for you. We also have our partners. It's Zvieriev community, it's EPAM, it's DevBuy, and it's community days. So these guys helps us a lot. And also we have communities who helped us a lot to deliver this conference. Here you can see a lot of logos. All of them helped us with this conference. So if you are not subscribing them yet, please subscribe to them. And if you see communities which is in your location, you can subscribe to them. All of them can be found on our VR community page. So please follow them. Also, we have our Instagram. You can find it by java.conference there. And we have some nice reels, which were created by our team and our speakers. So I hope you enjoyed it. And also we'll have something with that during the conference. So it's definitely worth to subscribe. Also, we have our account on X/Twitter, Java on Conf. So you also can subscribe on our Twitter. Not a lot of stuff there, but still we have it. And not only me, not only Evgeny brought this conference to you. So this is a huge team. Let me show you these guys. So first of all, it's Java On Program Committee. You can see these faces. These guys select best talks from a lot of submissions. And I can say that this year we have really a lot of. So these guys are responsible for delivering these talks to you and for this conference. But not only Program Committee, also we have a big Java On team. So it's administrators, designer, marketing teams, etc., 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 technical team, of course. So these guys are also here to help us. And also we have special thanks to even more people who joined us. And you see Evgeny here, who's on the stream with me. Yeah, so these guys also help us with on the conference. Thank you very much to everyone who helped us making this conference happen. So what you can expect from the conference? So today it's Wednesday, 15th of November. So we will start with a wonderful talk from Grace Jansen, and after that you will see Ivan Zvieriev, and in the end of today Vadzim Kavalkou will present his talk. So these are 3 talks for today. Also, tomorrow we have 3 talks. So tomorrow we will start from Alexander Kichev. After him, there will be Peter Abelnagi. And after him, there will be Evgeny Borisov. So these are talks for tomorrow. And on Friday, we also have a great line. So we will start with Hunor, as far as I remember. I don't remember the order, honestly speaking. But I think we will start from Hunor. Then it will be talk from JaCoV, then from Adam. And in the end, from Josh Long. So this is our lineup for our conference, but it's not everything. Like talks is not everything with what we would have on our conference. We have some online activities. All of these online activities you can find on our page. And I think after I finish with presentation, I will show you our page, how to search over it. So we have 3 online activities. First one is make a photo, post it with tagging our Instagram, and you may win a prize. I think we'll have some raffle on that. Next one is nice 2 nice quizzes, a journey through cinematic universes, and quiz on Java. So you can take part in these activities to have fun and to win some prizes. And also, like, about the first activity, so here we go. While I'm watching Java on, yeah, it's me. This is actually the photo from previous conference, but I will make another one and post it and tag our Instagram account. So I really encourage you to do the same. But online activities is not everything. Also, we have offline activities. All of them can be found on our page as well. And I want to really thank our local communities to make these offline activities in some locations. So here you can see offline locations which join this opportunity, and I'm pretty sure some of them now watching us. So hey guys, and some of them will watch us other days, so we will send them hellos other days. So guys, they're gathering together in offline mode, in current world, in offline mode. That's incredible. And watching our conference, so that's really great. If you are in these locations, you may join them as well. So yeah, that's it for my presentation. I want to say that enjoy the conference. And before we drop into the conference itself, let me show you the page, right? So this is VR community page, which I mentioned several times. You have a link in the description on YouTube if you're watching on YouTube, or you are on this page if you're watching us on VR community. So here we go. Here you can find the program for all days. Like everything is here. So I mixed up a bit speakers on the Friday. So yeah, first would be JaCoV, and then Hunor, and then Adam, and then Josh. So yeah, but you can find all the actual schedule here. And in the top of the page, you may find online activities I mentioned. So here they go, and here you have buttons to follow. So this is first thing. Also here you can find offline events, which are happening in different locations. And here you can find informational partners, which I mentioned, all these communities. You can search for a community in your location and join it. So yeah, that was mostly it from introduction. So Evgeny, I have a question to you. What are your expectations of this year conference?
As usual, actually, there are a lot of the different interesting topics that might be discussed in the so close connection with the speakers, and actually to have everything that I may gain from these talks to have it in the practice. Yeah, so that is a very natural way to learn things, to come to the conferences and to attend, to ask some questions that might be painful for you. And is my so as far as I actually attend a lot of the different conferences, I may say that Job 1 is a unique one. It is unique because it is too concentrated regarding the practical skills that might be increased during this conference. That's why, so the main part of the expectation is gaining something new, and another one is having fun for these 3 days, so is in the community of the great people. So That is my expectation. What is yours one?
Yeah, well, mostly the same. When you spend so many time in preparation to the conference, it's really hard to expect something because you know everything what to expect. So I do hope this conference will go well. And yeah, some technical freezes which can happen. So we're still in online world. They will be eliminated. So yeah, I think Evgeny will come back to us very soon. So while we're waiting for him to come back, let me tell you just a small thought. So Evgeny already mentioned that you can post your questions to our speakers and you can post your comments on what's going on, like anything. So basically, you can do that in two places. One place is on YouTube. Here we go. So, hey, Roma, here you have a chat on YouTube where you can post a question. We will monitor it and we will take all your questions from there. Also, there is a chat on Where community platform. So here, if you join our conference page, you can join online. You will join us. And here you will see also the chat right there. So you can also post your questions here. Me and Evgeny will monitor both sources to look for your questions. And in the end of each talk, we would pronounce your questions to our speakers. So this is how we work. And I made a recursion here, so I will turn this page off, not to recurse anymore. So Evgeny, you're back finally.
Yes, I'm here.
Okay, and I think it's time to invite our first speaker to our board. So guys, let me introduce you our first speaker of JaVoN 2023, wonderful Grace Jansen. Hello, Grace. Welcome to JaVoN.
Hi, thanks so much for the invitation.
We are glad to having you. Can you maybe give us some hint? What would your talk be about?
So we're going to be looking at combating some of the challenges and the struggles that we face as modern cloud-native Java developers.
Okay, sounds really interesting.
Yeah.
So, do we know how many Java developers already fought in this battle with cloud native? What is the percentage?
I feel like even if you're not using it in your day job, because I understand that some people are still on premise, or you might be using monolithic, but we're developers, we're curious, we love innovation, so you're probably already trying it in your free time, or at least as a side project or something fun to do. So you're probably struggling with it in some other sense anyway. So I would say almost 100% of developers have at least tried it in some sense and come up against these struggles and these frustrations. So hopefully, this presentation will give an idea of maybe where things like platform engineering, internal developer platforms, how these can come into play, how they can help. So hopefully it'll be an interesting presentation. I appreciate you guys all joining me today.
Yeah, I'm pretty sure, and I also heard, and I want to agree with you here, that if developers are not fought in this battle with cloud native, they at least thought of that, and it's like, okay, I tried to run my cloud native build locally. It took me 24 hours. I shut down my laptop and went away. So that's definitely what I heard.
Yep. I think that's something that a lot of us have experienced before, and hopefully there'll be some GIFs and some memes that I think sum up our feelings quite well. So hopefully you'll see them throughout the presentation and relate to those feelings.
Okay, I think we can not waste time anymore and just dive into the first talk of JaVoN 2023. So while Grace, we ask you to share your screen and we move it on the board. Guys, again, thank you very much for being today with us today, tomorrow, and on Friday. We're really glad that you are with us. So your questions, please post them in YouTube and in chat and the Where community. We will monitor all of them. And in the end of the talk, we will ask all these questions. We're here. Grace, good luck, and let's go.
Great. Thank you so much, guys. And thank you to everyone who's joining today. I know you guys have super busy schedules. And so I appreciate your time today joining the JavaOn conference and joining my session. So yeah, my name is Grace Jansen. For those of you who've not met me before, I'm a developer advocate at IBM based in the UK. You'll have to excuse my voice a bit. Sorry, I've picked up a bit of a cold or something, but hopefully we'll get through this presentation without any issues. So I've had a bit of a weird journey into tech. I actually did a biology degree, mainly focusing on fish and marine life, and then moved into the world of technology after graduation and sort of have moved into this world of Java and then into the world of cloud native. So I've kind of seen this from a different perspective coming in without perhaps prior knowledge or prior experience on more traditional monolithic style applications. So it's been interesting for me to observe from this sort of outside perspective in looking at some of the struggles and the challenges that we now face as a development community in Java when we're trying to develop modern cloud native applications. And that's what we're going to focus on today, and how things like, as I said, platform engineering, IDPs, and sort of technologies and tools that are available for this can help us when it comes to sort of trying to tackle these issues and these struggles. My Twitter handle is there, so if you don't already follow me on Twitter, feel free to do that. Twitter, X, whatever you want to call it. I'm going to try and get around to your questions at the end. If I don't get around to them, then please do feel free to tweet, tag me, message me, however works best for you. So without further ado, let's get started. So the first question I want to ask is sort of, why do we care about trying to get our applications onto the cloud? Why are we trying to develop these modern cloud native applications? And I think it's this feeling. Hopefully you're familiar with Toy Story, so you'll understand this. If not, go and watch Toy Story, great movie. It's this feeling that we get as developers, this, ooh, the cloud. We get excited about the cloud because the cloud allows us to have all of these innovations, these key behaviors and characteristics like flexibility, portability, scalability, resiliency, the innovation within the cloud that we can take advantage of by being able to utilize it through platforms. So all of this gets us excited, and that's why we want to be able to take advantage of all of these key characteristics in our own application by developing for the cloud. However, it doesn't always feel like this. It's not all butterflies and roses and sunshine. A lot of the time, how we feel and what we were just discussing is actually when we're developing cloud native applications, we feel a bit more like this. It's frustrating. We can't get our builds to deploy. It works on my machine, but it doesn't work in the cloud or on someone else's. It can be a very frustrating process developing for the cloud. So how can we turn this back into this? And hopefully this is where platform engineering can help us a bit with this. So here's the agenda for this presentation today. We're going to take a look at how we got to this position in the first place, looking at some of the developer struggles that we currently face, and then we're going to dive into what platform engineering is, how it can help us, what internal developer platforms are and how they're different to internal developer portals and how they all fit into platform engineering. We're going to take a look at what benefits all of these offer for us as developers and some of the tools that we can utilize to be able to perhaps start this journey towards platform engineering, or at least try it out, check it out, and investigate. And then at the end, I'm going to have a summary and some helpful resources in case you want to further your learning and go beyond just this session today and learn a bit more about the topics that we're covering. So what the hell happened? So let's have a look at how did we get to this position in the first place? So I quite enjoyed this meme because I felt like it sort of embodied many of the spirit of developers when it comes to this sort of attitude towards, well, we'll just shift everything left. And this increasing cognitive load that we then face as we're moving so many responsibilities back to the development team itself. You know, this sort of shift left mentality of, well, now that you're building it, you should also run it as well. But kind of this feeling of, I just want to run away instead. So the fact of the matter is, as we've moved towards modern cloud native development, we've started moving towards not just app development. We're now, as well as having sort of, well, we used to have traditional dev and ops teams, and we sort of chuck it over the fence and not really deal or look at what happens once we're trying to deploy it. Now developers are expected to enter a world of DevOps, FinOps, MLOps, GitOps, DataOps, DevSecOps, BizSecOps, BizDevSecOps, BizDevSecFinMLOps. Could there be any more ops? This list just seems to be ever growing. And what it results in is this shift in responsibility that increases our cognitive load as developers. So if we take a look at traditional app development, here's the split that we kind of used to have traditionally in app development. So you can see the light blue is the dev responsibilities and the dark blue is the ops responsibilities. So here we have developers looking at mostly the applications and maybe a bit of the app build. However, on the ops side, developers are very happy. They get to focus on what they love, creating innovation in the application. But on the other hand, the ops side have a huge number of responsibilities here that they're trying to deal with, and equally are getting little to no help from the development team because they're just chucking it over the fence. However, as we start to move towards cloud native and modern app delivery, what we tend to see is this shift of a lot of the responsibilities now moving onto the shoulders of developers in line with those different types of MLOps, DevOps, FinOps, etc. So now dev is kind of responsible for a wide variety within the app lifecycle. So not just applications, not just app build, but now we've got to look at things like how do we deploy our app? What runtime are we using? What Java are we using? Guest OS. We might also be partially involved in the entitlement or the billing because we're deploying to the cloud, and we've got to be aware of how much we're spending in that regard. And on top of this, we now have increasing demand when it comes to the application on things like usability, quality of our code. Are we able to observe our code when it's being deployed to these distributed and remote environments? So suddenly we've got a heavy load onto our dev team. And on top of that, our ops team's now trying to get their head around Kubernetes. Maybe they're using Docker, for example, containerization. How do we now deploy into this cloud platform, this cloud environment, and all these new skills that they're going to have to pick up as well? So we've kind of got a stressed out dev and an op that's having to learn a lot of new skills and isn't necessarily comfortable in this environment. So where do we go from here? This sort of movement, I liked this quote that was from Humanitech's Luca Galanton. The movement to shift left has forced developers to have this complete end-to-end understanding of an ever-increasing amount of complex tools and workflows. These tools are often infrastructure-centric, meaning that developers have to be concerned with the platform and the tooling their workloads run on, as well as the application itself. So it's this huge growing amount of cognitive load that we're having to take on as developers, which is really leading to burnout, frustration, and sort of this feeling of the fact that you're never going to be able to understand or take a hold of everything. And this sort of quote leads on to the fact that it's not just about cognitive load. It's also this ever-increasing amount of tooling or choice that we have when it comes to how do we do each part of our software lifecycle. There is so much choice. In fact, there's so much choice, I made a little game out of it. So a clear example here is the cloud native, what I like to call grocery store, but this landscape that's been produced by the CNCF Foundation. And I've added Waldo or Wally to this just to show how hard it can be, even to find one single tool in this mass of many, many, many tools that we can pick from for various different aspects of our app development, whether it be the runtime, the underlying platform, the infrastructure, the observability, whatever part it is. There's a huge choice that we can choose from in terms of the tools that we use for these things. So I'll see if any of you guys can spot it. Do let us know in the comments if you can. I have made him slightly bigger than some of the other squares, so you should hopefully be able to see him given a bit of time if you really zoom in on your screens there. But for those of you who weren't able to spot him, here he is. But the whole point of this exercise was, there is a wide array of tools. So not only do we need to be learning many different other responsibilities and aspects of the software development lifecycle, but we're now also having to take on responsibility of which tools do we pick? Are they right for our application? Do they meet the requirements that we have? Do they meet the regulations that we have to keep up with? So it's a huge array of choice out there that we're now having to also comprehend and deal with. And this leads me on to some of the developer struggles that we face. So one developer struggle that I wanted to sort of point out is this CI/CD tooling. So I quite enjoyed this meme on the right here. Again, hopefully sort of a lot of you will relate to this whole, you start to learn Kubernetes and then you think you're almost there, and then you discover Docker and you're like, right, that's another thing, I'll learn that. Then you get to Kubernetes and you're like, oh yes, okay, I know Kubernetes now, I'm ready for cloud native. And then you realize that there's a whole load more to cloud native than just containers, Docker, and Kubernetes. So it really is a steep learning curve in terms of our CI/CD tooling. And it takes time for us to be able to learn all of this, as well as the fact that there's so many options out there for us to choose from when it comes to which tools we use in this sort of pipeline that we're creating. Even when we start looking at open source standards that are supposed to be sort of the standard, there's still a plethora of choice, which does make it hard for us to be able to pick just one or make sure we're picking the right one for our application. And then on top of that, we've got to think about, okay, now we're deploying into this remote distributed environment that's often complex and chaotic. How do we make sure that we're able to effectively observe our applications to make sure they're behaving as we intended or as we expect them to? So again, All of these make CI/CD tooling aspects quite difficult for developers, one of our struggles or one of our challenges. Another one is container management. One doesn't simply run a container. It's not quite as simple as this. There's a lot that goes into running a container effectively, especially when we're deploying to the cloud. This includes not only ownership of that container, but also things like cost. We're now having to work as a DevOps team rather than just separate ops. We have to be thinking about the ops side of this. So how are we deploying and maintaining and running these containers in production? The great thing about containers is obviously it gives us that portability and flexibility, but there are many decisions involved when it comes to running and maintaining our containers. Which tools do we make use of? How are we configuring our environment? Is it as efficient as possible while still allowing for that high flexibility, resiliency, and high performance as well? How do we build our apps and enabling that within that container management system? It's also challenging when we have this ability to be able to run as separate teams within our own organization, developing different parts of the same application. It's challenging for us to be able to ensure consistency and stick to best practices across every environment that we have, across all of our teams, when we have such flexibility in which tools to use, configuration options, and sort of where and how we're deploying our containers. There are tools that can help us a bit with this. So things like operators, for example, or cloud native build packs can help, especially when it comes to sort of knowing what images that we're using, where have they come from, for example. And I've actually done an article on cloud native build packs. So if you've not come across this before, this tool, check out the article that I've linked to at the bottom of this slide. It runs you through what a cloud native build pack is and how it can be helpful. However, this doesn't solve all of our issues, especially when it comes to consistency, best practices, and sort of simplifying this process, because there's still a lot to be considering and to sort of a lot of cognitive load in this task here. And another one is security and regulatory requirements, which sort of links to those best practices that I was talking about before. When an organization has created a product and they want to sell it to sort of a large enterprise, excuse me, it often requires things like compliance certifications before you can actually GA it or sell that in a specific market or a geography. So things like the Data Protection Act, especially for healthcare data, ensuring that we're complying by specific geography regulations, like we might have to have our data hosted in a specific location. And on top of that, there's also the fact that we have to be considering things like, well, many of us are utilizing open source software. Do we know what is in our applications? Excuse me. So having a software bill of materials to be able to understand what's actually within our application. Is it safe? Do I have vulnerabilities that I need to be aware of? Do I know where I'm getting this software from? Is it a trusted source? Having that understanding of, are we aware of the vulnerability, not just in our own source code, but in the images we're using or any external libraries that we're dependent upon? Do we have a trusted software supply chain? And do we have any compromised credentials, for example, in our own source code itself? Excuse me. So these are all struggles and concerns that we face as developers. On top of this, there are also other struggles. So for example, the likelihood is you're probably already drowning in scripts and maintenance costs. You might say today you'll just hire more DevOps, but this doesn't really scale when we're talking about huge, large organizations. Another thing is, no matter how hard you try, you'll probably not reach the degree of automation possible because you don't have the necessary scale that you want. Another struggle that we face is key person dependency. Often you'll have a key person so that you will be dependent on, whether that be in ops or another team. So any maintenance update depends on someone who knows exactly what configuration to change and in what file. This works great in the first year, but the average job time in our industry is just 1.4 years. So this constant churn, as well as the fact that we're dependent on this person, and they may not necessarily have the skills or the knowledge right away, can cause that blockage or that potential bottleneck in our sort of software lifecycle. On top of this, every time a dev needs a new environment, they have to interrupt a colleague, often in ops, and wait for its creation. In the most extreme example, we've seen an automotive company that took over 3 months per process. So it can be a really long time, depending on how your organization works, just to create that new environment that a dev might need. And environments can also get blocked in testing. If you need to ship something, you then can't. If you have to run a hotfix, your team is out of the game entirely. So these are all struggles that we face on top of those other three that I was talking about when we're trying to develop effective modern cloud-native Java applications. And all of this put together can make us feel a little bit like this. Okay, this might just be me, but this feeling of like, I don't want to deal with it anymore. It's all too much. And this isn't just me feeling this way. There are studies out there that have shown, so for example, this is Salesforce. This is a study by Salesforce in April 2022 that shows that the top 3 causes of developer burnout includes increasing workload, like I was talking about, all those responsibilities shifting onto us from other teams, pressure of digital transformation. We are trying to move to the cloud, and this also increases pressure on us as developers to get our applications there, and requirement to learn new skills. There are a bunch of new tools and skills that we need when it comes to deploying our applications and developing applications effectively for that cloud native environment. All of these 3 are the top causes of developer burnout. In fact, 76% of organizations in this study say that the cognitive load is so high that it's causing angst and actually low productivity for their developers, so having a negative effect on their overall output. So clearly this isn't just me coming across these issues and observing them. This is being observed in many different organizations around the globe as we're moving towards these cloud native development. I quite enjoyed this Twitter poll from Luca where he was saying, Debs, do we really want to be doing ops? Like, be real with me. I enjoyed some of his answers that were applicable there, but the answer here is the majority of people in dev didn't really want to be bothered with the ops side of things. A lot of developers just want to be developing applications, going back to that happy dev that we saw in the previous sort of traditional style of application development. However, we do need to innovate and we do need to move towards the cloud. So how can we utilize methodologies and tools and principles to be able to go back to the sort of happy developer, but still enable this innovation? And this is where things like platform engineering can help. The fact is that most developers require the same sort of technologies, and often it can be standardized across the board. For instance, let's take the consolidation around Kubernetes and containers, infrastructure as code, and the need to implement sort of similar build configurations and security policies across applications. This could potentially be standardized across your organization. So by outsourcing the maintenance of tools for shipping and running your applications to a common platform, we can then hopefully take the burden off developers and free them up to focus on their code. So it's kind of this idea of platform engineering is all about kind of centralizing DevOps tooling to help us enforce more governance and build out internal standards, which can help with reusability and overall deployment agility. This is a growing topic of conversation, one that's really become sort of at the forefront of many organizations' minds as it moves up in the Gartner hype cycle. So as you can see, it's here in this sort of innovation phase right now, but it is expected to move up into this sort of peak in the next few years. This is the hype cycle for software engineering from Gartner from 2022. So you can see it is growing in popularity within organizations. So what is platform engineering specifically? What does this phrase really mean? So this comes from platformengineering.org. Platform engineering is the discipline of designing and building toolchains and workflows that enable self-service capabilities for software engineering organizations in this cloud-native era. Platform engineers provide an integrated product, most often referred to as an internal developer platform, covering the operational necessities of the entire lifecycle of an application. So from this, I've really pulled what I think are the key aspects of what platform engineering really means. Essentially, it allows us to have these sort of workflows. Often they'll get referred to as things like golden paths or paved paths that enable self-service capabilities. So we're no longer having this key person dependency. We can self-serve as developers ourselves. We can self-serve into the cloud. And this is all enabled through this concept of an internal developer platform, which we'll get onto in a minute. So really, platform engineering is this discipline that's focused entirely on sort of enhancing developer productivity and happiness, because we're going back towards that, just focus on your code. We'll automate the rest. We'll standardize the rest. It's this sort of developer first infrastructure sort of principle that we're trying to follow and improve this developer experience. So the aim of this is really to reduce the complexity and the overheads while enabling frictionless and self-service capabilities for organizations who are trying to develop cloud native applications. Many of you might look at this definition and say, right, okay, well, DevOps, we've seen on the Gartner hype cycle, DevOps is platform engineering is growing in popularity. Platform engineering is the new DevOps, so that must mean DevOps is dead. We've got to move on from DevOps. Actually, I'd argue that DevOps isn't necessarily dead. I quite enjoyed the summary that's provided in this meme here. So we start off with this phrase of, well, platform engineering is the future, DevOps is dead. But then we realize that actually we need to utilize DevOps practices and tools to actually build the platforms that we need in platform engineering. So we still need DevOps. It's just evolved into this concept of platform engineering. It is often quoted as the next evolution of DevOps, but this practice doesn't necessarily supplant it. It just is the next evolution. So, it's something to consider that actually, if you're already utilizing DevOps in your organization, you can utilize that within platform engineering as well and still use the same tools and skills to be able to ensure you have great platform engineering, great platforms. There are actually considered 6 foundational pillars that comprise sort of platform engineering, and you'll recognize many of them from DevOps principles. So we have things like security. The first thing a developer asks when they start using any system is, how do I create an account? Do I need to set up credentials? How do I get an API key? Talking about the security behind your application and making sure that that's first and foremost when you're setting up your platform engineering platforms, so that that's consistent across everything that is involved in platform engineering. Talking about security right up at the forefront to show how important that is. We've also got things like pipeline. One of the first steps in any platform team's journey is integrating with or potentially re-architecturing the software delivery pipeline. So taking a detailed look at an organization's version control systems and continuous integration and continuous deployment pipelines. There's also then provisioning. So in these first 2 pillars, so security and pipeline, the platform team is providing this sort of self-service CI/CD pipeline workflows with security baked into them as guardrails right from the outset. These are the first few steps, but once you have the application code to run, the next question is, where are you going to run it? So every IT organization needs an infrastructure plan at the foundation of its applications and platform. So then platform teams, this is what this provisioning pillar is all about. It's about providing the way in which that we can essentially enable that infrastructure. Where are we going to be deploying that application? Then we go on to connectivity. So network connectivity is often hugely undiscussed in terms of DevOps, with many legacy patterns and hardware still in use in many enterprises. So it's important that we add this as a key pillar in sort of platform engineering. And this brings sort of the automated speed, reliability, and version control traceability benefits of infrastructure as code to networking. So it really allows us to be able to connect into sort of modern dynamic environments and bring networking functions, softwares, and appliances into their infrastructure as a code configuration. We then got orchestration. So when it comes to actually deploying your application workload, if you're working with distributed applications, it's going to be much easier using a workload orchestrator. So enabling that through this sort of pipeline that you're building, this platform, as you will. And then the last one is observability. As I mentioned, really key for us to be able to observe how our application is performing in reality when we're deploying it into these distributed environments. So observability is that last key pillar. If you want more on this, there is actually a white paper that I've linked to at the bottom here, which goes into each of these in a great deal of detail. So do check that out if you are interested. So essentially, by going through each of these pillars and considering each aspect of them, we're going to be putting together our own sort of platform engineering pipeline or platform for developers to be able to utilize in our organization. Essentially, you can think of it kind of like you're collecting together ingredients to be able to bake your own platform. So the key ingredients that we need for the platform engineering recipe are dictated by the sort of tools that we need to utilize in every aspect of our software development lifecycle. So it goes right the way from, okay, which IDE do we want to standardize? Which one are we all going to use? Through to, okay, what version control system are we using? Are we using GitHub, GitLab, whatever it might be? Going through to resources, container registries, for example, which runtime are we making use of? Going through to observability, so are we using Instana, Dynatrace, Datadog, looking at vulnerability scanners, CI/CD tools, things like GitOps tools, for example, infrastructure as code, if we're utilizing that, like Terraform, Ansible, Pulumi, Crossplane, there's lots of different ones to choose. So it's all about collecting together the ingredients that you choose in your platform engineering team for your whole organization, so that you can then bake together this platform for your developers to be able to use as that self-service platform. So once you've picked together all of these things, this is where it all comes together in these different aspects of the software development lifecycle. You can see here this sort of, again, we're going back to DevOps principles to be able to bake together your own platform. So the way it looks is a bit like this. So we take all these ingredients together, we're baking them into this internal developer platform, and the developers are able to access this through the internal developer portal. The internal developer portal and the platform and sort of who chooses the ingredients might differ depending on how your organization is set up, but often you'll have a platform engineering team who's in charge of this process. They're taking on the responsibility of these aspects of this software delivery lifecycle. So what do these individual parts actually mean? We've spoken about internal developer platform and about internal developer portal, but what are these definitions? What are we talking about here? So when it comes to an internal developer platform, I've shortened this here to IDP. Now, we're in tech, we absolutely love acronyms. You might hear an internal developer portal also referred to as an IDP. Little bit confusing. So I just want to make sure that we're clear that in this presentation, I'm talking about the platform and not the portal when I say IDP. What this is I've taken this diagram here from Configure8. It's a company that offers a proprietary IDP. And as you can see, I thought I liked this diagram because it kind of showcased that IDP being in the center there, the developer portal connected to it to act as sort of a face, which we'll go into in a minute, and those different various plugins and sort of infrastructure that's sort of connected into that central platform that we're able to utilize through it. So what an IDP is it's a central collection of tools, services, and automated workflows that enable development teams to be able to rapidly deploy and deliver software. They provide a service layer that helps to abstract away the complexities of infrastructure management and application configuration. So it really allows us to be able to sort of minimize the cognitive load for developers without abstracting away important meaning. The key part here is sort of why these three words were chosen to describe this. Internal, it's trying to make a clear separation between this type of platform and an external facing platform, like Twilio's developer platforms, for example. They are external facing. IDPs are meant for internal use only. Developer, really indicating the internal customer and the primary user is going to be the application developer in your own organization. So making sure you have that focus on this is a platform for developers internally in my organization, and platform just characterizing the product type. So platform engineering is about delivering products to development teams that allow them to focus on the problems they're trying to solve instead of solving the problems of how to actually deliver the solutions. And IDPs are a way of enabling that. They're custom built by a platform team by combining different tools and technologies together. And they might be services, they might be open source, they might even be self-developed, whatever it might be, with the intent to then increase developer productivity and velocity. So IDPs allow us to be able to have these golden paths or these dedicated workflows that are already paved out for us. So as developers, we can just jump right on that bandwagon, follow that paved or golden path to be able to easily get our application up and deployed into the cloud, utilizing infrastructure that's already been approved. How are they used by developers? They actually integrate right into our existing workflows, which usually remains a sort of a git push deploy workflow, but with some further automation added in. The entire deployment process is now at the disposal of the developer, hopefully, so they can request resources, spin up fully provisioned environments, they can roll back, deploy, and set up deployment automation ruling all autonomously through this platform. So a modern developer should only need really 3 panes of glass: the IDE to code in, Git to be able to merge any code that we want to merge, and an IDP to be able to actually ship and run it. So that's where it kind of comes in terms of the workflow. But it should be really straightforward and easy to use. Often, this last pane of glass comes to us in the form of an internal developer portal. You don't necessarily have to have one to utilize internal developer platforms, but they can be a really useful tool to use to be able to provide that sort of interface into those golden paths, into that platform itself. Depending on the maturity of the IDP, it provides several interfaces and access points that can be as basic as a CLI, It can be different kind of user interfaces, or it can be a fully blown developer portal with a service catalog to be able to unify all of this developer experience together. So what is an internal developer portal and how does it differ to the platform? So the portal here, as I mentioned before, is really, it serves as this interface through which developers can discover and access the internal developer platform capabilities. So it provides this face of the internal developer platform, and it allows that sort of self-service element of platform engineering for them to be able to access the single UI, for example, to be able to operate those operations and actions, and also offer visibility into the infrastructure through that observability that we talked about earlier as well. So it can be a really useful tool for this. So combining internal developer portals with internal developer platforms together allows us to have this sort of seamless developer experience for very quick, easy, high velocity workload and high productivity from our developers. But the key thing here to remember is that internal developer platform and internal developer portals are different things. You can use both when it comes to enabling platform engineering in your own organization. Okay, so what benefits does all of this theory bring to us as developers when we actually get it in reality? So taking a look at the organizational impact, looking at some of these responsibilities, you can see that there's a big shift from what we saw originally. Now, if we have the platform engineering team, that platform engineering team is the one that's taking on many of the key tasks when it comes to how do we deploy that application into the cloud itself, which means that developers are now freed up to focus on what they love, which is developing the application itself, enabling innovation within that application. And the nice thing is that platform engineering can help to standardize that these different elements, these different responsibilities across the organization. So we're not duplicating work unnecessarily, and allows us to have this idea of this paved path or golden path through the internal developer platform. And now the ops can just focus on the elements that they're familiar with and sort of can really be clear on which responsibilities are theirs versus the platform engineering team or development. So things like host virtualization, the hardware that we're utilizing, entitlement or billing might be shared a bit between platform engineering and ops, depending on how your team works. But really the key part here is we freed up developers a lot, taken a lot of that cognitive load off and enabled them to have this sort of self-serve capability through a seamless experience that isn't as stressful necessarily, because they might be worried about all of those security vulnerabilities or regulations or whether they're doing the right thing. And this sort of leads into the qualitative benefits. There are qualitative and there are quantitative. And often the qualitative gets missed out, but it can be some of the most important benefits of methodologies like this. So how does it benefit development teams? Well, the first is, as I mentioned, enabling that standardization and enabling sort of secure key delivery processes through golden or paved paths. So this enables them to be able to have increased developer productivity while still ensuring that they are utilizing secure pipelines with tools that are recognized and chosen and approved by the organization in a way that is as effective as possible. It enables this through this internal developer platform, which enables this self-sustainable, self-responsible teams. So we're now able to sort of, this is arguably the most important element, I would say. And these platforms are what allow us to be able to really rapidly build and test and deploy and monitor applications with real minimal friction. Teams that are using IDPs are entirely self-sustainable and become self-responsible. They run the entire end-to-end process, and this self-reliance means that nothing is being thrown over the fence, and the ownership level increases without the friction level increasing between teams that can decrease. And then the last one is the simplicity of DevX, having a reduced cognitive load. So the fact that we're able to provide paved or golden paths can help to reduce the cognitive load and complexity often placed on cloud native engineering teams. It simplifies that vast array of different tool choices we can make into a simple list of necessary tools to master, and enables developers to be able to be more productive by spending more time focused on enabling business value. It also offers developers a safer environment within which to perform tests and experiments by utilizing the security guardrails that we were established within this platform or as part of this work. So it can really help with these qualitative sort of elements. On top of this, as I mentioned, there's also quantitative benefits. Often when it comes to changes within software organizations, we have to prove to those higher up that it's going to be beneficial and show them numbers to prove this. So here are some of the numbers that Humanitech's study actually proves in terms of quantitative benefits that we see in development teams, including wait times decreasing by 90%, average deployment frequency up by 4 times, visibility and transparency across teams greatly improved, onboarding time greatly reduced, and lead time greatly reduced as well. So this was a study that Humanitech did on teams that have built an IDP internally. That included GitHub, Zalando, Sport1, as well as teams that have built their own IDP with Humanitech's technology. And this data was evaluated by surveying these teams 6 months before they adopted an IDP and afterwards, so they could really see the difference. So you can see here some great quantitative impact on some of the organizations, but obviously this does depend on the organizational setup and size, because while smaller teams won't experience a lack of standardization and related pain points, enterprise organizations with hundreds or even thousands of developers deploying even thousands of times per day will greatly benefit from building and adopting an IDP. So this can change depending on how your organization is structured and how large it is, for example. As well as benefits to the developers, there's also quantitative organizational benefits. So as well as we can see some of the developer stats on the left there, there's also increasing benefits for platform engineering. So for example, there's a 95% reduction in configuration files that they need to be maintaining and enabling, and a 75% less maintenance overhead. For the organization itself, 30% faster time to market, and 80% lower TCO for your enterprise grade IDPs. So this is all, again, this is a study by Humanitech, but there was also a recent Forrester snapshot that was taken where they found that 74% of DevOps leaders say that improving DevOps with an IDP boosted their developer productivity. 77% said that it could shorten time to market, and 85% that it drove revenue growth. So this is really, this isn't just about enabling your organization to be happier and to enjoy their job more and to enable, it actually has repercussions on the revenue that you are able to generate within your organization. However, this isn't to say that this is the magic answer to every organization. There are obviously challenges that do come with enabling this within an organization. So as well as that increased developer autonomy and reduced time to market and increased developer satisfaction, like we were mentioning, there are challenges like the fact that, so for example, many larger companies have faced issues with supporting a large organization with a very small platform engineering team. So that's a potential strain that we could come across on that platform engineering team. Sometimes it can be difficult to manage or standardize configuration or tools across an organization if there are many different paved paths that are necessary. Platform engineers have the challenge of also ensuring the user configuration is precise for user authentication and authorization to be able to actually access that IDP as well. So there are some challenges still that we do need to be aware of before jumping fully into something like platform engineering, because this is still a lot of work, which we need to be aware of. Okay, but there are tools to help. Now, it's important to note that there is no single open source tool that will give you an entire internal developer platform, an IDP. But if you can, if you wish to create your own, you can basically combine multiple different tools together, like things like Argo CD, Crossplane, to be able to manage your Kubernetes workload and infrastructure, with Backstage acting as a service catalog. So you can combine together lots of different tools to create your own IDP. But there is no single tool that can just magically create one for you. However, there are tools that you can utilize to be able to enable elements of them, or enable that developer portal that we showed, which is that interface to your platform underneath. As well as that, there's also reference architectures that you can follow, which can help pick which tools you want for each particular part of this IDP. So some of the reference architectures, so for example, McKinsey & Co., this bottom diagram here, they spoke at PlatformCon 2023 about their research looking at hundreds of real-life platform setups, and they uncovered common patterns in IDP architectures. They then distilled all of these patterns into 5 architectural planes differentiated by scope. So it's shown by this diagram here. So we're looking at these different subgroups of the developer control plane, integration and delivery, monitoring and logging, security, and resources. There are also specific architectures that are available. So for example, the one at the top here from Humanitech, on different cloud platforms. So if you've already bought into a specific cloud platform like Google Cloud, for example, or AWS or Azure, there are reference architectures for each of these, which are available from Humanitech. You can download the PDF to find out which tools people are using from these specific platforms for each of these various subgroups. They share the same subgroups here. So this can be a really handy tool to utilize and take a look at if you're just starting out with creating your own IDP. As well as this, platformengineering.org has also expanded McKinsey's original IDP reference architecture, the one on the previous slide, with this tooling landscape. So it's a bit like the CNCF Cloud Native Foundation landscape that we saw earlier, but this is specific for IDPs. So this tooling landscape adopts the same umbrella subgroupings that I was talking about before, but also includes other pluggable tools as well. This is a great place to start from as a blueprint, which can be really helpful to stop that sort of initial roadblock to getting started with this, because it might seem like a bit much and you don't know where to get started. This or the reference architectures are a great, fantastic place to start and to look at for you to start building out your IDP and making those tool selections to bake it all together into that IDP. On top of this, there's also other open source tooling that we can make use of. So if you've not come across Backstage, definitely go check this out. The link is there, backstage.io. This is a project that was donated by Spotify and is now a CNCF incubating project, open source. It provides you with an open platform for building developer portals and also provides this sort of centralized software catalog. And there are lots of different plugins that are now available for Backstage. Out of the box, Backstage includes the Backstage software catalog. This is for managing all of your software, so microservices, libraries, data pipelines, ML models, whatever it might be. Backstage software templates. This is for quickly spinning up new projects and standardizing your tooling with your organization's best practices. And then there's also tech docs, Backstage tech docs. This is for making it easy to create, maintain, find, and use technical documentation, kind of like a docs-like code approach. There's also a growing ecosystem, like I mentioned, of open source plugins that further expand Backstage's customability and functionality. So it's a fantastic tool to be able to take a look at to start off with. So definitely check that out. Building on top of Backstage is Janus. There's lots of different ways to say this one. This is actually a Red Hat sponsored community. It is, again, open source and it extends Backstage. So it's been developed and it's got additionally developed and enhanced Golden Path templates, Backstage platform and plugins. It's there to provide you with a highly configurable and secure development portal and that catalog to control which components can be built together, kind of like those building blocks to be able to build out your IDP. So Janus is great. If you want something that's more enterprise, Red Hat Developer Hub is built on top of Janus, which is built on top of Backstage. So kind of going all the way through it here. One note on this is that it's only available currently to a limited set of customers as a preview, but it is hoped that this will be out fairly shortly. But if you are interested, Janus is obviously the underlying open source, so you can go and check that out to see what Red Hat Developer Hub might be like. But this is really focused on that enterprise grade sort of quality in terms of providing a product for those enterprises who want something like this. And it allows an open developer platform for building open developer portals. It contains a supported and opinionated framework offering some of those sort of golden paths or paved paths, and it offers extended functionality through a set of predefined supported plugins. If you are interested in finding out more, there's a really great YouTube video on the bottom right, which gives you a preview into what this tool offers. They are hoping that it will be out, generally available in the second half of this year, which is obviously kind of coming to a close soon. So we're hoping it's going to be out soon. But this is a really great project to take a look at if you like Backstage and Janus and want something a bit more ready for the enterprise. Another open source tool is Kratix. So this is an open source cloud native framework for building internal platforms specifically on Kubernetes. You can go check it out at kratix.io, or there's a really great enlightening video from Whitney, which I've linked to at the bottom here, where she goes through it with one of those light up light boards and really details out the sort of ability and features and functions of Kratix. What it allows is for us to be able to co-create capabilities between development teams and platform engineering by having this sort of premise of promises. A promise is comprised of 3 elements: an API, so input from an app team to create resources from a capability, a set of dependencies necessary for any created workloads, and then workflows, so business logic required when a resource is requested. So this sort of promise, all these 3 elements, is what allows us to be able to create the IDP and enable these paved paths as promises. It supports platform teams to be able to easily deliver this sort of curated Kubernetes native platform API. So another open source tool that's really interesting. Other options that are available, there are already proprietary options that you can go and check out and see if you like the look of. So things like Port, for example, Configure8, Cortex, Rody, Compass, there's loads on here. There is a list in the link that I've got at the bottom of this. internaldeveloperplatform.org has a list of some of the potential available. Many of these are offered as SaaS or PaaS. So if you are interested in more of a pre-curated, pre-built platform that's supported for your enterprise application, then these might be an option you'd want to consider. And that is something that's worth noting, is that there is a wide array of different IDP implementations when it comes to actually implementing this in your own organization, all the way through from sort of just starting out, getting your platform engineering team up and running, through to creating, a specific IDP to your organization that's completely made from scratch, all the way up to utilizing some of these PaaS and SaaS offerings, sort of pre-built, pre-configured, available to you. So do bear this in mind that you might fall somewhere on the spectrum. No place is necessarily the right place. It's different depending on your own organization and how you're set up. The important thing to consider is that just because a lot of people are building platforms does not mean that it's easy to build. This is not an easy alternative. This is an effective alternative, but it does take time and work. Most developer platforms aim to reduce complexity and give that self-service access, but the balance is paving this path is different for every organization, particularly when you consider the fact that there are different kinds of developers in different organizations. Developer platforms are not there, the internal developer platforms are not there to cater for every developer in your organization. It is there for the 99% developer who build most of the real world applications, often rely on legacy software versus the sort of vocal minority or developer influencers that might be doing the super cool stuff with innovative things. They might need to sort of build on top of the IDP themselves and take responsibility for that. IDPs are there for the 99% developer and aren't there to provide a golden path for every potential thing that you might need to. So it's important that you strike this balance between how many golden paths that you offer through the IDP and that you strike this balance between how much of that do you want to create yourself versus how much of that can you get from open source or other frameworks that are available out there. Okay, so where is this sort of heading? Where is this going in terms of the future? And this, I think, is based around 2 different questions. The first is this whole, how much should you be building yourself? And the second is, how should you be assembling the control plane as well? So I think there are 3 avenues for future innovation within this space. The first is this idea of sort of ready to go golden paths. I think we're going to be seeing more and more companies offer predefined, pre-configured golden paths for us to be able to pick up and go with. It's all well and good when you're a really large organization, being able to put in the resources, put in enough people into your platform engineering team to build completely custom IDPs. However, when you're a slightly smaller organization, it can be difficult to be able to have enough people, have enough expertise, have enough skills to be able to create that completely from scratch and completely custom. And so I think we're going to see a lot more people looking for pre-configured, ready-to-go golden paths from different organizations or runtimes or platforms. Another way in which I think we see the future here is persona expansion. Right now, we're pretty much solely focused on developers because they are the primary user of this platform. However, in the future, I see sort of this persona expanding to perhaps other close supporting roles other than just dev. So things like enterprise architects, QA engineers, data engineers, or even people further afield like security or finance or HR. The fact that we have these fantastic insights and metrics that we can collect through the portals and platforms, all of these other supporting roles could also utilize. Many of them often rely on manual data collection analysis. So maybe being able to use a self-service portal with access to that infrastructure and applications could enable them to also be more effective and productive, and even maybe gain further insights. And the last one is this idea of programmatic. It's kind of, I guess, another persona, but in this case, we're talking about machines, sort of allowing them to also consume that data. So could they use this plethora of data or analytics to help businesses or departments drive decisions, for example? Could it be used to make decisions on pipeline executions, not just using APIs to push data in, but also pull data out and drive processes within your org, linking it maybe into AI and machine learning as well. So I see lots of avenues in which this could develop in the future as well. So with that, I'm just going to quickly summarize and give you some of those resources that can help you take this to the next step and further your learning and further your development within this space. So hopefully from this presentation, what I've shown you is that yes, our cognitive load and the demands on developers are ever increasing as we move towards modern cloud-native Java development. However, developers can be supported and helped through these various different methodologies and platforms. So platform engineering, internal developer platforms, internal developer portals, and the ability to access those golden or paved paths. Now, what this looks like will be specific to your organization. How much do you want to build yourself? What is your team structure? What does your development need? All these questions will come into play with that. But you can utilize the tools, the technologies, the reference architectures, and also examples from other companies that have already started this journey are already out there for you to utilize and refer back to when you're starting out on your journey within this space. That kind of leads me on to my resources. So as I said, there are lots of different examples out there of organizations who have already started on this journey that you can learn from. We've obviously got the big companies like, for example, Netflix and Spotify, who have helped to sort of engineer and create many of the open source tools that are now available in this space. However, there's also smaller companies here or mid-sized companies like, for example, Sneak, Twilio, and smaller companies like the Veterans United Home Loans. So there's some really great resources here for you to check out to see how have other companies done it, what choices have they made, and how have they achieved that, and what benefits have they gained from it as well. There are some fantastic resource references that are created by the various different companies like Configure, for example, Configure8, and also some of the other companies that offer those proprietary products that we went through earlier and those tooling. They do a lot of different podcasts where they have recordings with a lot of these companies who've started out on this journey. So do go and check them out. In terms of resources specific to platform engineering, there's a growing community within this space and thus a growing number of resources that you can refer to. So the guys over at InfoQ have created this very useful platform engineering guide. You can download it as a PDF. So do go and check out that first link if you want sort of a summary reference of what I've spoken about today to be able to show to your team and say, this is platform engineering. I think it's great. Maybe we should try it. There's also things like PlatformCon. I've mentioned it a few times in this presentation. Some of my links do link to recordings. This is a conference that is created literally around the platform space, and previous years' sessions, their recordings are now available freely on YouTube. A lot of them are about 15 to 20 minutes long, so not too long. They get straight into the nitty-gritty, and you learn a lot in a short space of time. So I'd really recommend those session recordings. There's also a platform engineering Slack channel that you can join, and a weekly newsletter, Platform Weekly, as well, if you are specifically interested in signing up to those. Otherwise, here are some additional resources, just in case I hadn't given you enough homework already. So things like the benefits of platform engineering. That first link is helpful for that if you want more in-depth insights, as well as the ones that I referenced in the qualitative and quantitative slides. There's also a link here from Configure8, one of those proprietary providers, listing out what is the difference between a platform and a portal. Just in case that wasn't entirely clear in my presentation, you can refer to that second link. Tools for your IDP creation. There's a really useful Medium blog here that you can go and check out for that. And then IDP reference architectures, you're available in that second to last link. And also looking at what's next in terms of this space, a really great video from the PlatformCon 2022 edition from Daniel Bryant, who's one of the leading experts within this space. So do check that out. It's only about 15 minutes long if you want to go further into the future element of this specific topic. But hopefully those resources are useful and sort of cover right from the very start of like, what is it, through to why does it help, through to how do I do it, through to what's next. So covering the various different elements we've looked at within this presentation. So with that, I'm going to say thank you so much for joining me and sticking with me through this presentation. Hopefully it's been useful for you. We'd love to have feedback. Shout out on Twitter or LinkedIn or in the comments here in the chat, and I'll take a look at them. Really appreciate your time. If there's anything I don't get around to, do contact me on either LinkedIn or Twitter. I'll be there to answer any additional questions you might have. Thanks so much.
Yeah. First of all, I want to say thank you very much for this great talk. I have no words. Just awesome. Thank you very much for bringing it to us. So we have a lot of not of questions, but I would say more comments about this talk. It looks like audience is attracted. So if you want to know, we have around 800 people looking at us right now. So yeah,
that's amazing.
Yeah, so not all of them are really active. So guys, I encourage you to leave your comments. If you don't have questions, just put some smile or anything to the chat. So we would really appreciate that. So Evgeny, let's start from a question from YouTube first.
Yeah, let's go through the questions. And Grace, yes, thank you so much for your talk. It was amazing. So regarding the question, one of the first
Okay,
I've lost him.
Yeah. So we have some freezes. So yeah, this is online conference, guys. Everything can happen. So let me grab this. let me grab this stone here.
Sorry for that.
Oh,
so there was a kind of the glitch. So yeah, so first question that I would like to ask you is regarding your day-to-day activities and the tools that you use on the daily basis, especially that might be related to this talk for the internal development platforms and so on. Are there anything that you may suggest, maybe that is created by IBM or a kind of a team kind of the tools here that are highly used by your environment around?
Yeah, so my team mostly work on an open source runtime called OpenLiberty, and I definitely, please go and check us out. I run the OpenLiberty socials, so I'll say hi if you come follow us on social media, either Twitter or we're on LinkedIn. It's a cloud native runtime that can really help if you're looking at developing cloud native Java applications. It's modular, really lightweight, and it interacts and implements many open source standards like microprofile and Jakarta EE. So please do go and check that out. It's openliberty.io. We have a bunch of interactive guides there that you can even do online. So you don't even need any prerequisites locally, which is great. We're super proud of it. So please do go check it out. We'd really appreciate any feedback you have on it. But yeah, go check out OpenLiberty. It's on my t-shirt.
Yes, that sounds great. Yeah, thanks so much.
And I want to give a comment. So guys asking in chat, where can they find slides? So we will ask Grace to send us the presentation and we will pin it to the talk on We Are Community Platform. So you can find link to We Are Community Platform in the description on YouTube, if you're on YouTube, or if you're on We Are Community Platform, you know where to search for. So there you will find the presentation and all the links. And thanks a lot for so many resources. Yeah, it's really, really awesome.
Glad it could help. I'll definitely be sharing them.
Yeah, so we also have more questions on the platform. So question is kind of provoking, but I will ask it. So could you possibly estimate to what extent using platform speeds up the delivery?
So if you go back to my quantitative, I believe that's one of the ones that we saw in there. Yeah. So for example, average deployment frequency, this is up by 4 times. So instead of just being 1.5 times a week, we're up to 6 times a week. So you can see this is real data from real companies implementing IDPs from Humanitech survey. So a 4 times increase, which is great.
Okay, and second one, even more provocative question, I would say. So it's just scroll on. So does using platform make developers happier?
So I think there's always going to be someone in your organization who doesn't like a change like this. Not all of us are excited about innovation and change, and we like the way we've been doing it for many years, and that's understandable. However, I think most developers would be happier to know that they can just focus on the application code and developing innovation in that space. Because if we wanted to be in ops, we'd probably be in ops rather than in development. So I think on the whole, it does make for happier developers because they can just focus on the application code.
Yep, that sounds great. So I guess that is all from the questions from the chat, but I have my own one.
Yeah.
Actually, as far as I have got experience of working with the platform teams, there is a kind of the things that always makes me annoying, and yeah, that is a good time to ask such kind of the question to you. When we are talking about platform teams, they are working on some kind of the platform features, right? And that is so great when I require it in my team. Yeah, from the front end perspective, from the back end perspective, it doesn't matter. But they have their own estimations. What do you have a kind of the receipt how to efficiently negotiate with them? Yeah, to push it to the top of their priority list.
Yeah, so that's actually one of the good things about Kratix. So that was one of the open source tools that this one here, because it is really that co-creation between development and platform engineering. Because you've really got to think about the fact that in this, like in IDP development, you've got to think about your developers as your clients. So really, you should be developing a platform that suits their needs best. So it should really be a co-creation between the two of you. So this particular tool allows you to be involved in the prioritization of features through the use of those promises. So if you're interested in that aspect, I'd definitely check out the Kratix tool.
Okay, yeah,
Yep.
and I have, I think, last question from my side. So yeah, we have a lot of comments like, thank you very much for the presentation and brilliant talk. So yeah,
Thanks,
people really
guys.
enjoyed it. Yeah. So last question from my side. I remember, I think around 10 years ago, there was kind of such talks about DevOps practice.
Yeah.
So there was like this, okay, guys, so we're struggling, right? There are developers, there are admins, and now at like IT, and now we have something, should have something in between. So now we're speaking about having something in between devs and SREs, basically, which are now DevOps, right?
Yeah.
What are your forecasts? Will we have in the future some more talks, maybe even from you? Like, okay, guys, so platform engineers is, yes, they struggle. Now we should have something in between. What do you think?
I think it's inevitable because all of this is evolving at such a fast pace that we're never going to get it perfect first time. So we've got to be flexible in understanding that our organization structures might change, our responsibilities might change, the way we deploy applications might completely change. Who knows? But that's what's exciting about being in software development, is because it changes so fast, so quickly, and so with such great changes and great results. So I think it's kind of inevitable that we will have another talk in 10 years' time, but hopefully it will be for the benefit of all of us.
Okay, sounds great. So we'll wait you for with next talk.
I'll be back.
Great. Thank you very much. Thank you very much for this great start of the conference. Thank you very much for your talk. And yeah, we have a lot of comments for you to get well very fast
Thank
and
you.
soon.
Sorry.
So yeah, no worries. You did your like very best, and we're really glad that you still with us. So thank you very much for this talk.
Thank you, guys.
Thank you.
Thank you. Bye. What a great start, huh? I think that was just amazing. So, guys, yeah, we continue. We're not stopping. So, yeah, before we move to our next speaker, yeah, I know that our schedule is a bit tough. So you have just like a couple minutes to run away for some water and to pick it up. So I want to do one small thing. So I have my phone in my head. So in my hand, I mean. So I just take it, turn it off, like turn it to the front camera, do it like this, and done. So yeah, during next talk, I would post it to Instagram. You may see our Instagram like here, so somewhere here. Yeah, so it's java.conference. So post it, tag us there, and you can win a prize. So how you watching Java on conference? It's really important for us to see real people, because when we do online, when it's offline, you just sit in the one room. You can turn to sides, and you will see these faces which are smiling or not at the talk, at the content. So it's really, really important to see some reactions. That's why we ask you to write us something in the chat, to push like button, to send us some smiles. Yeah, that's really important for us to see some reactions from you. So let's invite our next speaker. I would say our next speaker is Zvieriev, and the one we are glad to have in our studio. Hello.
Hello. Hi, guys.
Hello.
everyone.
How you doing? How you feel about
I'm
Java?
fine. I'm continuing Grace tradition to come sick to the conference.
I
So
do hope
if
it won't be tradition.
if I will be coughing from time to time, I'm sorry for that. But what to do?
So
it's this period,
I definitely think we need to move our conference somewhere from November. I think that's the
Definitely.
problem.
It was a long ride.
When kids are bringing, like now I have one kid in kindergarten, another in school, and they are like bringing different set of viruses. Now it's even more tricky.
Okay, guys. So for all our audience, please be safe. I don't know. Wear warm socks. Prepare some tea with lemon. So yeah, please be safe. It's November, so a lot of viruses around. So Ivan, can you share with us, maybe in some words, what your talk would be about?
I guess I will do that in the beginning, but in general, every time I speak about something, it's about low-level Java in this or that regard. So today it will be more about high-frequency trading, low-latency financial systems, and compilers. Initially, I wanted to build something around compilers, but then I understood that maybe it will be interesting to hear like compilers is only part of it. So, yes.
Okay. Great to hear. So a small reminder to our audience that we are monitor two chats, one on the YouTube and another one on VR community platform. So you may post your questions, comments, reactions, whatever, to these both chats. We want to hear from you. We want to see your reactions. I know there are a lot of people who are watching us. So please show us yourself. Show us that you are there and watching us. I think we can dive into the talk. What do you think?
We can. I'm ready.
So please,
Then
so
let's
please
start.
share your screen. And yeah, I will ask our operator to show it to all of us. So guys, yeah, reminder, Instagram photos. Yeah, on Where Community we have online activities. Please join them. All 3 days conference will be live. They are there, so you can take part in them anytime. Yeah, I can see Ivan's screen. So Ivan, good luck. Let's go.
Thank you very much. So let's go, guys. Welcome. Thank you very much for coming. I'm really happy that you came today, and I'm happy to be with you. So today's talk is Java compilers. Why is Java a suitable platform for low latency systems? And low latency systems are is a must for example, high frequency trading. And we will speak about like high frequency trading, compilers, and answer the question why Java is suitable platform for that. I will start with myself. Yeah, I'm Ivan. I'm 7 years with EPAM, low latency fun, more than 10 years in IT. I don't have a specific hobby. I'm hobby collector. I'm switching them like every 3 months. I don't know. That depends on the hobby. Here is my Twitch. Sometimes I'm doing streaming. Not lately too much, but sometimes, occasionally I do. And let's go straight to the agenda. So first, we will have some brief overview about you've heard a lot about low latency. Yeah, low latency. We will dive deep what it is. Then I will show you example architecture of how high frequency trading low latency systems look like. Then I will show Java platform and tools to support such systems. So I will show how Java actually helps to build this kind of system. And in the end, we will speak about Java compilation, because it will be mandatory part, about Java C, about tiered compilation, about metrics with JVM collects, about optimization the compilers do. Let's go. So low latency. I will start with a story, because I started my career like 10 years ago, and that time Java was not about the speed. Yeah, very often I've heard that the speed is the problem of Java, actually. Someone was showing benchmark of Python. Of course, C and C++ is out of the question. Java was slower, yeah, and this was my pattern for quite a long time. Yeah, we can do amazing enterprise applications in Java, but it's not very suitable for low latency and some very speedy systems, let's say. And I was under this impression until I tried myself to one of the low latency projects. And I had a discussion with one of solution architects here in EPAM. And he told, yeah, of course, Java is like one of the first options to build low latency systems. And I was like, how is that? How is that possible? Java can be slow. Yeah, it's not possible. C and C++ is faster. And he says, come on, Ivan, this was like 10 years ago. You're a dinosaur. You need to read a lot about new things which were added like in recent years to Java. And this is exactly what Roma, what you were asking about, like what is the talk about? The talk is about to prove that Java is very, very good platform for low latency. I would say that one of the first choices. So, first of all, before we will go to definition, I would like to cover what domains actually are suitable and where low latency is definitely required. Yeah, so the one which is like I can say about my experience, because I worked in 2 projects related to low latency, is financial services. Yeah, so high frequency trading and electronic trading platforms. Currently, they have a really high requirements to the latency. Yeah, so high frequency trading is the trading when the order is opened and closed within a second. So you open the order, 2-3 tips of the price, and you close it. Yeah, so definitely no human interaction. Everything is automatic, algorithmic. Etc. No trader looking at the graphs and taking the decision. And you understand that within a second, the request should go to the platform, to the exchange, should be opened and closed, and everything within 1 second. So yes, we need low latency for that. Second thing, gaming. Everyone likes playing games, and everyone hates lags. Yeah, and like you don't want to throw your mice in the wall when your game is lagging and you lose because of latency. Telecom, yeah, everyone wants good communication, good quality of sound, of video. So telecom is definitely one of them. Now we can combine like automotive, military, space, and aviation all together, because they pretty much require this for their autopiloting system. Yeah, so we don't want our Tesla to send REST request and receive some response in case if it detects that another car stopped abruptly, and you need to take decision really fast. So low latency is here suitable, especially military, space, aviation, everything here as well. Also, there is one important thing which seldomly is mentioned. High performance computing. So some scientific research is actually space exploration. Yeah, they require very heavy computation. Maybe low latency in general, like latency is not required, but the speed of computing is very important for such huge computation. So this is one more domain. And now go into the definition. What is low latency, and actually how low we can go? Low latency refers to the minimal delay or lag in the transmission of data or execution of a process in a system. I will not go to too much details in figures, numbers, graphs, etc. There is an amazing talk by Daniel Shaya, not very fresh, but in this world, even talks from 2013, they are still, in many cases, are relevant. It is called exactly like this. How long can you go? Ultra low latency Java in real world. So if you are interested in like details, you can watch this talk. I will give just a small example from financial world, how we can define low latency. So a lot of exchanges provide such a service for their customers, which is called colocation. It means that the market players put their servers right on the premises of the exchange, near the servers of the exchange. And in USA, there is an official like federal law that if exchange provides such a service, they are obliged to provide equal access to all traders, which means that every trading server should have the same length of fiber to the exchange, because the longer the fiber is, the longer request can go, yeah. And in high frequency trading, low latency is actually when the length of fiber matters. Yeah, so that was amazing for me to know that people could think even about like length of fiber cable, and this can really matter. Next topic, just to give example understanding how architecture of high frequency low latency system looks like. Yeah, so this is exchange. Exchange is clearly like their servers on their side, and they provide the data feed. Yeah, so they provide some data to market players about market, about prices, about orders executed, etc. So it is going to some market data receiver, which is already on the side of the player. Yeah, so some trader. Trader is receiving this market data, and based on some strategies, for example, it can be not a single one. It can be multiple strategies. They are taking the decision about doing some operation. Yeah, so we decided to buy stocks, or we decided to sell stocks. There is a trigger which is going to order management system, which is later sent to the exchange for execution. Yeah. Sometimes when collocation come into place, there is even can be some super fast strategy with dedicated some transport, which will receive, which will send the orders to the exchange, even without like without applying those, let's say, slower strategies. Yeah, and there is some trade monitoring backend. Yeah, some backend services which we need to keep our system stable, keep our system monitored, etc. So this is like high-level overview. Now let's have a look. What do we need to achieve that? It's definitely not a comprehensive list. This is something that I consider like the most important. And the first three items, this is something that you as developers, me as developer, cannot too much influence. Yeah. So first of all, you need fast hardware. Yeah. So this is up to company to buy like amazingly fast computers. Geo proximity. Yeah. So this is collocation, which we were talking about, and this is really important. Even if you are not ready to pay for collocation, it makes sense to place your servers in the nearer to the exchange where you are going to work. If this is London exchange, then somewhere in London. If it's New York, then somewhere in New York. Last but not least, this should be designed before the whole system is built. It's security. In low latency system, you cannot on every request check some tokens or doing some encryption, decryption. This is too slow. So the best possible way to minimize security efforts to build some external perimeter. Yeah. So if you are collocated with Exchange server, then most probably it will be much easier. Yeah. So, but this security thing should be thought very much in advance, and it should not be included in the end system, in the end logic, which I just showed on the diagram. Now, something that you can influence, and this is the first of all, code efficiency. Of course, we need your code to use optimal algorithms, to use optimal data structures, etc. Next thing, fast transport. Definitely, we see that the system is very complex. And to have a single monolith could be tricky even for latency reasons, because you will have to do a lot of operations in a single application, which is not very desirable. That's why you most probably will go to some distribution by microservices. And in order to have that, you need to have fast transport. Yeah, so to transfer information from one service to another, and also from Exchange to our servers, and from our servers to the Exchange. Next, very important things is effective work with memory, and we will go in depth with that. It's not only like macro world, it's on macro world and micro world. More details will follow. Effective concurrency. We all know that concurrency is making our applications faster. But to be completely honest, in low latency, concurrency can make your application slower, because you don't think too much when you write concurrent code. You don't think about how much contention you can have on definite resources. Yeah, you cannot predict that. And concurrency must be very smart in such systems, as well as logging and persistence, because logging and any other input-output, yeah, this is very expensive operations, as well as persistence. So those three things, I combine them later in one, but they are very, very important to have this designed really smart. So let's take our favorite Java platform and see how we can build such system using Java tools. And let's start with fast transport. Yeah, so typical enterprise application uses something like REST, Kafka, SOAP, GMS, RMI, TCP, file sharing, whatever, name it. Yeah, but what is it if it is not fast enough? Yeah. Here, I wanted to give some joke about UDP protocol, but I was afraid that you might not get it. And this was a joke. So UDP protocol is extensively used in high-frequency trading. And this was a huge surprise for me. I knew for sure that UDP protocol is not reliable. Yeah, we cannot guarantee sequence, and we cannot guarantee delivery. And for financial service, which must be 100% precise, this is not acceptable. And I was wondering that UDP is not, we cannot use it. So how do we do that in general? Why have you ever thought why UDP is not reliable? Yet, so TCP, UDP, pretty much similar things. Why UDP is not reliable? Now let's imagine how UDP works. Yeah, we have two buffers. sender buffer and consumer buffer. Producer buffer writes some data. Consumer buffer recreates the same data on its side. Yeah, so in one place, in another place, we have two copies, and then we read from our buffer. Yeah, what will happen with TCP if you will not read fast enough? Most probably, if you will not read fast enough, TCP will not write because it doesn't receive confirmation that it was read. Yeah, it was read, and TCP will stop writing. And that's the way how TCP guarantees the delivery, the sequence, etc. With UDP, it's like, are you getting? I don't care. Yeah, just send everything. So it's broadcasting. So the smart way to make UDP not fail is read at least at the same speed as the producer writes. But in the very smart systems, your reader will be much faster than the writer. Yeah, and if you will read everything from with the same speed as producer is writing, your UDP will not fail. Yeah, I have seen this. This is something that I have seen on production system, that we didn't have any single case of UDP failures in weeks. And what to do if it still fails? Yeah, so there is no guarantee by documentation, by specification. There are no guarantees. What to do if UDP fails? First of all, the most regular approach, as everywhere, is two UDP buses. Yeah, so if we expect something and we didn't receive it from single bus, we immediately ask the second bus. The second two, I would say that this is a patterns for using UDP protocol. This is sequencer and rewinder. Yeah, so we send the datagrams with sequence number, and on consumer side, we are expecting the next number. Yeah, and if we didn't receive it, we either ask the second bus, receive it from there. If it's not there as well, then we enable the rewinder. We are saying, guys, we have missed, like we expected 13 and we received now number 17. So please rewind us data from 13 to 17. Yeah, and we continue reading the data to some buffer while we are rewinding. Yeah, and then processing this rewinded data. So this absence of guarantee is not crucial because there are ways to overcome it. But we already discussed how to make UDP not fail. There are other possible solutions for transport in Java. First two are actually designed, and those are two big frameworks for high-frequency trading systems. They include not only transport, they include also special data structures and special concurrency frameworks to make high-frequency trading really low latency. It's Project Iron and LMAX Disruptor. And they are really used very extensively in many exchanges, in many market players are using them. So you can check in the end. By the way, this is just for the whole presentation. I've collected the list of links if you will be interested in some particular topics. The links to Project Iron and LMAX Disruptor are on this list. So the last slide will be collection of those links. You will see that there. More exotic, I would say, is TIBCO FTL, and this is a commercial solution, so there is no, I guess, free tier. Also fast queues provided by TIBCO. Next, NATCO is something very fresh. and I cannot confirm that it will work, but they declare that they are really fast, and you could read about that. KDB Plus is very interesting framework as well. It is mainly like in-memory storage. It is used for in-memory persistence. Plus, it also provides transport capabilities. So now we see that we have UDP, we have some framework solutions suitable for that, and this problem is covered. Now, second very important problem for low latency systems is effective memory usage. Why it is important? In low latency systems, you cannot allow yourself full garbage collector, because even if you have a very efficient collector, etc., if it will stop the world for like half a second, you will have a huge problem. Yeah, in one of the projects where I worked in practice, full GC was a production incident. Yeah, it was like we were monitoring the logs of garbage collection, and we definitely knew that garbage collection doesn't trigger. Yeah, if it triggers, it's an incident. And the best way to effectively use memory in Java is avoid GC. Yeah, and for this there is a talk actually by me. I've done it on JDD, I guess, a couple of years ago, about the techniques how to write the code not producing any garbage. The link is available. You can have a look. And what else you can get from that? Actually, you can reduce the overhead of garbage collector, which G1 and those like special like regular garbage collectors have. If you use serial GC, for example, serial GC is single thread, and you know that it is not going to trigger. So you just enable serial GC, or if you are brave and you can enable experimental features, then Epsilon can work for you. Yeah, Epsilon is like a garbage collector, which is in general doesn't collect any garbage. It just gives you as much as heap as it can, and when it fails, it crashes your application. Yeah, so simple, nice, and suitable for this use case. The next very important thing is avoiding heap resizing. So in low latency systems, you will not see standard, not tuned parameters for initial heap size and maximum heap size. Usually you start with already huge heap. You don't start with a small heap like in regular. If you don't change any settings, yeah, standard Java application will go with like, I don't know, 512 megabytes heap, and once it like goes to filling, it will like increase the size until it reaches the maximum heap size. In our case, the best scenario is minimal heap size is the maximum heap size. Yeah, so if you understand that your application needs 32 gigs, then you start with 32 gigs and never resize it. Later, you will see one more reason why avoiding heap resizing is a very good idea for low latency. The last but not least, with latest JDKs, we received two garbage collectors. Shenandoah, I guess, is still is in like experimental features, but ZGC became production ready starting from Java 15. So in 21, it received upgrade, very significant one. It became generational. So ZGC like declares that it has 0 pauses. Yeah, so there is no like not a zero stop the world. In fact, I guess there are micro nanoseconds of stop the world still can happen, but I would not say that it's complete zero, but it's very close to. So other solution for effective memory usage is using specialized garbage collectors. Also, what we can say, ZGC and Shenandoah, those are two available in Oracle JDK, in OpenJDK, but some JVMs, for example, Azul, I know that they have some own garbage collector, M4 or C4, yeah, which is also like declared to be special low poses, special garbage collectors intended to be used in low latency systems. So at least three points we have mentioned how to effectively use memory on macro world. And now let's go to micro world. Yeah, I guess everyone knows that Java uses processor caches. Yeah, and there are three levels of caches: L1 cache, L2 cache, L3 cache. And please have a look at the data. Yeah, so reading from L1 cache is taken usually from 1 to 3 nanoseconds. Reading from L3 cache is like 10-30 nanoseconds. Reading from like the best possible RAM, it's DDR4. I was looking at like the latest possible RAM. It is written that it's like from 500 to from 50 to 100 nanoseconds. So you see the price of cache misses, right? And that's why you need to effectively use memory on this micro world. Yeah, so you need to utilize those caches very hard. That's why you want to avoid resizing of your heap. Yeah, so once you will have garbage collector triggered, once you have a new memory allocated, all the caches need to be populated or repopulated. Yeah, so all caches can be invalidated. Whatever can happen, yeah, with the caches when you try to reallocate the memory or clean up the memory with garbage collector. And you understand how it will work. Yeah, and now we will speak about one thing which is usually used, warm up. Yeah, so everyone heard that we need to do warm up before our application gets up to the like optimal speed. And usually we say that warm up is about like it does compilation, a lot of methods are compiled, etc. But warm up also speaks about caches. Yeah, so once you do a warm up of your application, a lot of caches are already populated, and you will start reading not from main memory, but from caches once your application is warmed up. That's it about effective memory usage. Let's go further. How to utilize caches, let's say from your code perspective, not from settings perspective. First of all, it's important to use the first two points. They are interconnected. Yeah, so the best way to utilize caches is to use cache-friendly data structures. And this is the structures which are sequential in the memory in your JVM. Arrays is very good example. Ring buffer is also a good example. Linked list is awful example. If linked list hash map, for example, this is a not cache-friendly data structure, and you cannot. You will have a lot of cache misses if you will use not sequential access structures. And what is data locality? Even if you have sequential array, for example, it will work perfectly if you will iterate one by one. Yeah, so starting from 0 and ending with length. If you will pick the one one element from start, then in the middle, then in the end, etc., it can again cause a lot of cache misses. About minimizing memory allocations, we spoke already. Thread affinity. This is like a special topic. It's very hard to achieve, but it can be achieved, and there are special techniques for that. so that you know that something that already started to execute on one thread, it should continue to execute on that thread. Yeah, because wrongly told. Thread which started to be executed on one processor core should continue be processed on the same core. Yeah, so just imagine you have 4 cores and you have 4 threads. Yeah, each of them is executed on the single core. It's all fine. But what if you have 8 threads? Yeah, it's amazing that when shifting of those like scheduling of threads is happening, they are still stick to one single core and not transferred from one to another, because then they will not able to utilize the cache, because the cache is connected with the processor, with the core of the processor. Yeah, and thread affinity is very important part here. Yet it's very, very not easy, not trivial to do. Now about concurrency, logging, and persistence. As I told previously, concurrency should be very smart. Again, the story. Give me a second. When I was interviewed to one of those low latency projects, the interviewer was like out of 60 minutes, 40 minutes, he was speaking, he was asking me about concurrency. And we were like really, really deep in the topic, and 20 minutes for other topics. On my first working day, he started to show me the system and told, all our system is single-threaded by design. I was like, why? What is the sense to do it on interview? And he told that on interview, yeah, person should understand those concepts, but in fact, concurrency must be very smart. Most probably you will not be able to avoid it, because still you need to do logging and persistence. And this is like one of the smart way to use concurrency in low latency systems. Yeah, if your logic is executed in one thread, and logging and persistence are thrown in separate thread. Sometimes I have heard about the systems which even logging and persistence, they just separate to different service. So you just receive the data, do some logic, and push the data to some UDP bus to another service to log it, to like do persistence, etc. Your application doesn't care about that. Your application cares only about like processing the data and sending the order. That's it. Now to the main topic, code efficiency. I guess the developers most interested in this part. Let's speak about compilation. Yeah, so how compilation works in Java, and how you can make your code, not how you can make, but how Java makes your code. You write code as usual. You don't need to write some special things that to make it compiled in efficient way. JVM will do it for you. And it starts with Java C. I don't consider that Java C is a compiler, because it doesn't do like translation to machine instructions. It translates to bytecode. But a lot of optimizations are done already on this level. But further, we have tiered compilation. There are 4 tiers, and this is how it looks like. The tier 0 is when JVM takes your bytecode and starts to interpret it like standard interpreter stuff. Yeah, then after 150 times, 1,500 times of execution, C1 compiler starts to work, and it takes the it does the fast compilation without profiling. Yeah. Sometimes some code, and JVM analyzes that, it will not go even further. It will not go to any further tier. This is called trivial methods. Yeah, so when the compiler, when JVM sees that the method is very trivial, there is nothing to optimize there. It is good enough to compile it with C1. C1 is like more not primitive, but more simple compiler, there is no sense to throw it to C2 because there is nothing to optimize. Yeah. Then there are two tiers of limited profiling. So JVM do some profiling of your methods, and C1 can continue compilation if, for example, C2 queue is full, so C2 is fully occupied, then C1 can continue recompile your code to a more efficient one using the profiling information. Yeah, so limited profiling C1, full profiled C1, and tier 4 is like fully profiled code and fully profiled compilation with C2 compiler. So this was overall picture of how compilation works, and now to optimizations. Even before C1 and C2, like machine instructions, Java C is already doing a lot of stuff for you. So constant folding is quite obvious. Yeah, it's replacing mathematical operations with constants when possible. Dead code elimination doesn't require any explanation, right? Local variable type inference. Yeah, so var keyword, the new one from Java 10 or Java 9, Java 10, I guess. Now it's resolved on Java C level. Method inlining, yeah. So when you have like method call, it's more efficient for Java C to create bytecode so that it considers it as a simple method. So it just inlines your method to the different one instead of using invocation. It will help the efficiency. Constant pool optimizations. Everyone knows about string pool, about int pool, but JVMs usually also maintain other kind of pools which are not that popular, and they are used inside, and they are actually doing the optimization on both memory and efficiency. Control flow optimization. So loop unrolling, simplifying conditional branches, reducing branch instructions. Java C can analyze your if structures, loop structures, and optimize them already on this level. Yeah. String concatenation. Sometimes we do a lot of concatenation. You understand? Yeah, it's the same as constant folding, but with strings. On some JVMs, actually, I guess Hotspot and OpenJDK can OpenJVM, OpenJDK cannot do this, but some JVMs can do tail call optimization. So basically, when you write the recursion, it will optimize this to tail call. The same as Scala do, for example, in their way. So how Java, having like not having the compile in advance, how C or C++ can do, or Graal, for example, a head of time compiler can do, why Java can be the same fast and sometimes even more efficient than C++ compiled code is because it is watching. Yeah, it's collecting some data during execution, and it can use this data for profiling. So method profiling, how often the method is called. Branch profiling, how this or this if statement is called. Loop profiling, how often the loops are called. Tiered compilation info, what is already compiled, what needs to be recompiled, what doesn't need to be promoted from C1 to C2. This is another topic. Escape analysis, very important if you're still using concurrency. It can do escape analysis and check if the object which you consider guarded, like if you're doing synchronized blocks, if you are doing volatile variables, escape analysis in background, it's all the time watching if this can escape. And if it doesn't, sometimes this was actually very amazing news for me. Sometimes it can allocate the object even on stack instead of the heap. And this helps, again, fighting garbage collection and effective memory usage. Type profiling, I guess it's also not comprehensive list. It's something that I was able to derive, but there can be more. And now coming to like final compiler optimizations, which C1 and C2 do using this information from JVM. The first 3 lines are about loops. Yeah, compilers can heavily optimize your loops. It can split your loop, bigger loops to more smaller ones, and the other way around. Yeah, so if you have 2 very similar loops close to one another, they can combine them in one. Branch predictions. This is very important thing, and actually Alexei Shepelov has written a nice article about that. It calculates, for example, you have like if-else statement, and JVM has defined that your if condition is executed like 1,000 times and else condition is executed only once. It can even recompile your code the way that if statement will be closer in the code, in the machine code, than it is in your code structure. Eliminating that code, again, more advanced than Java-C is doing. It's already, again, based on some runtime statistics, on some things which are calculated on the runtime. It can eliminate those things. Escape analysis-based optimization. So this is something that I've talked about already. And there are more and more and more. There is really a huge amount of those optimization. Null check elimination, very nice feature. So if someone considers that maybe I shouldn't do null check, most probably we will not get it. JVM will eliminate it anyhow if it's redundant. If it defines that there is already a ready object and it's not null, it will remove it. Huge amount of those. And coming to outcomes. Yeah, so answering our question, is Java suitable for building low latency systems? Fast transport, do we have it? Yes, we do. We have UDP. We have, if we don't want UDP and we want some framework, we have LMAX and we have Iron, TIPCO-FTL. So these solutions are in place. Effective memory usage we've mentioned. Yeah, we have specialized garbage collectors like ZGC, Shenandoah, Epsilon, but we also can utilize techniques not to create garbage and to avoid garbage collection at all. Cache-friendly data structures, there are plenty of them in Java, like built-in, like arrays. Every sequential data structure will be cache-friendly. Ring buffers, which are actually actively used in LMAX, I guess, framework. But LMAX and Iron provides their own cache-friendly data structures as part of their framework. Then we have Java-C optimization. Then we have quick C1 optimizations. And then we have fully profiled C2 optimizations. And this is something like I told in the beginning, that Java can be even faster than C and C++. Yeah, why? Because C or Graal, which is like doing ahead of time compilation. So they do compilation once before start, not having this profiled information which we have seen JVM is collecting. In JVM, the process is dynamic. Yeah, so it starts with some basics, and then based on runtime information, it starts to make better and better and better optimizations. And these optimizations, in the end, when you have fully warmed up application and everything is like on the run, it can be even faster than anything you can do on ahead of time compilation. Links collections, as I promised. How low we can go, no garbage techniques, special talk about Shenandoah by Alexei Shepilov, LMAX Disruptor and Project Iron links. For those guys who are in general interested, like me, in low latency topics and low level Java, two absolutely useful resources, Shepilov.net. Alexei Shepilov is the author of Shenandoah. He's a very big contributor to OpenJDK. Also, he's the author of GMH, yeah, and he's having a huge blog about all those topics. The second is newsletter, Java Performance Tuning.com from Jack Shirazi. He's doing this newsletter from 2001. So the guy is very, very consistent, and he's really professional and really, really very useful materials. So if you're interested, please review those. With that, I'm thanking you for your attention, and Roman.
Yeah, thank you very much. Thank you very much for this great presentation. Thanks a lot. I see we have really hot discussion, I would call it, on the platform. So I hope you can join it after we let you go, because yeah, a lot of different opinions on low latency in Java. So that's really cool. So guys, a reminder, we expect your questions in YouTube and on the platform. And now I pass the voice to Evgeny to ask these questions.
Yes, thank you so much, Roman. Ivan, thank you so much for this great talk. So I will start with some kind of a provocative question, as usual. So let's think about such kind of a thing about low latency. Yeah, so in most cases, that is not a question about how fast we may do something, but how to control the worst case. Yeah, and not to actually fail with something that may take our time. What are the options to control this kind of the borderline and not to prevent it for the low latency applications?
I would say that for low latency, it's actually very much about not only outliers. Yeah, so the baseline is very important because again, when we were speaking about UDP, yeah, if your reader is slow and slow even not for a single case, but in general, yeah, you can start losing this data. Once you enable this rewinder, you are again like missing this. But when the outlier happens, this is definitely an incident. Yeah, and when outlier usually happens in the situation when you had for example, GC, when you had Stop the World, or you had some, again, this sequencer rewinder thingy is the reason for such outliers. Because outliers usually, when the system is working, they are not happening. Yeah, they are happening during some, like, the system was busy with something. Yeah, and you need, definitely every outlier should be investigated. Yeah, if you've noticed, if someone reported, or however your monitoring is working, every such case should be investigated in the rest, because if it happens very often, high frequency trading systems are based on the fact that they are working all the time. Once you missed 1 hour, you've missed money. Yeah, so that's a problem. And the best way to address such outliers, so usually you don't have them, but once you have them, you definitely find out the root cause. It's not something that we can allow to let go. You know, sometimes we can. I have seen that. Okay, it happens like once in a week, 3 users are affected. We don't want to spend resources on that. In such kind of systems, we are not allowed in that.
Yeah, yes, thank you so much. Let's move on to another question. In your talk, you also covered the topic that is related to the network protocols, UDP and TCP. Today, we are hearing a lot about HTTP3, which is based on the QUIC protocol, and may QUIC be interesting in terms of the low latency applications?
To be honest, I cannot answer for now. I haven't reviewed HTTP3 for now yet. I still HTTP3 doesn't provide transport itself, right? It's not a transport protocol. You still need to have some transport under the hood, and for such low latency systems, you don't need higher level. You work directly with transport protocols. Because I was wondering why you would need HTTP3 or in general HTTP 1 or 2 for such kind of systems. Yeah, you don't need to have a front end, as I told. So those systems are not like manual decision making. Yeah, and in those cases we are working directly with transport, and I guess it's worth looking at. Yeah, I didn't look at it yet, and I'm wondering how to apply HTTP in general to low latency, and can't find the good solution for that.
Okay, yeah, got it. Let's move on. Another topic that is very hot in terms of the enterprise world or application world, it is reactive and reactive frameworks. The usage like RSocket or R2 DBC or something like that. So are these frameworks interesting in the low latency? Because reactive seems like a possible marketing promotion as a being very fast, very sufficient for any kind of applications. But what is the reality regarding it?
Reality in my for example, in one of my projects was the following: no frameworks. We had JUnit, and this was the only framework, the only external dependency we had. The reason for that is not that we don't trust that they can be fast. They can be fast. We want to have the full control of what is working with the memory. Yeah. So if the framework is fast, extremely fast, yeah, it can be really fast, but it creates garbage under the hood. We cannot allow that. Yeah. And using the framework, first of all, we will need then to investigate a lot on the side of like those kind of things, not only the speed, yeah, not only the latency they provide. This is only one factor, but another factor is how much garbage does it create. For example, this is something that come into my mind, and if it does, we cannot allow that, because we want to have a full control. For example, when I was talking about LMAX and Aaron, they were intentionally designed for high frequency trading, and they don't. So they create garbage. I mean, they don't create garbage, and they are intentionally like they can be used out of the box without this additional check, I would say. Some of market players will not agree with me and will say that no, we will write still our own custom solution. We want to have like full control. That's why answering like directly the question, reactive frameworks are good and useful, but most probably those will be reactive frameworks because the idea of reactive, the whole low latency system is by design reactive. Yeah, so it reacts on the external event from market data which is coming in, but most probably those reactive frameworks will be self-made. Yeah, so I doubt that someone will take I don't know, Akka in their project, because what is going on inside there, we don't know. Yeah, and we cannot predict.
Okay.
And
Yeah, I assume that's it for questions. So thanks a lot, Ivan, for great presentation. Yeah, there are a lot of comments. That super great presentation. Thank you very much. I hope you can join the discussion in We Are Community platform in the chat. So guys, if you want to dive into the discussion about low latency with Ivan in our other participants, feel free to join them in the chat. A reminder, link to the platform is in the description. Also in YouTube chat, there is also some questions and discussion. So do that. Send us some smiles, send us your reaction. So Ivan, thank you very much for your talk, for being with us on this conference. Thank you.
Thank you for inviting me, and thank you all the audience for coming and for listening. I really appreciate that.
Thank you. So now you may join the audience. Thank you. Have a good evening.
Thank
Bye.
you. Bye.
So we continue our JaCoV conference day number 1. And before we move to our next speaker, I want to remind you that tomorrow we have second day. Tomorrow we'll have 3 great speakers as well. It's Alexander Kichev, Peter Abelnagi, and Evgeny Borisov. Join us tomorrow. And on Friday, we also will have one more day of JaCoV conference. 4 great speakers await for you on Friday. So stay with us. And a reminder, maybe you will miss it. So links to on YouTube will be different. So on platform, it's just the same link. On YouTube, it's different links. You can find all links in the description. So if you don't want to miss our streams, you can just click on JaCoV on day 1 or JaCoV on day 3, or JaCoV on day 2 or JaCoV on day 3, or on all of them, and click subscribe or send me notification when stream will start. So once we will be online, you will receive notification, and you won't miss our conference. So Evgeny, what do you think about day number 1? Do you like it?
Yes, exactly. So it is full of really amazing talks. Yeah, and I have already noted several frameworks that I need to revise, yeah, and look at it in a deep way. I'm expecting the same kind of the thing from the talk number 3. Yeah, that is actually going forward to us, and we are moving to it deeper.
Yeah,
and
I also
closer.
want to mention that I learn new stuff, not only from our speakers, but also from our audience. For example, about Quick Protocol, I understand I heard about it like a couple years ago, but I haven't touched it for a long time. So I go and refresh my thoughts about that. So just Google about it. That's cool. So thank you guys. Thank you for sharing your thoughts. Thank you for sharing your opinions. Thank you for your questions. That's really great. So yeah, we're moving to our last talk for today. And I would like to invite our virtual studio, our third speaker, Vadzim Kavalkou. Hello, Vadzim. Welcome to JaCoV conference.
Hi, everyone. Thank you that you invited me for such a great conference. I'm happy to be here.
Yeah, so I would say you're not the only speaker, but it's your second conference, right? So second in a row.
Yeah. This is the second conference.
Yeah, so great to have you again.
Again, thank you. I just like your merch, and I would like to receive one more shirt or something like that. So, the only point I'm at the end of the session.
Yeah, it's not a big secret. It's not even a secret at all. But yeah, all our speakers receive special gifts from us. So guys, if you want to be part of JaCoV conference and receive cool gifts, you may submit your talk next year. We will be glad to have you among our speakers. So Vadzim, just a small question. Maybe you can give us a hint what your talk would be about?
Oh, it's kind of about the cost optimizations. Nowadays, it's really painful situation on the market or all over the world. And if you can somewhere optimize the costs, it's really, really great and crucial thing could be. So mostly it's about it and the tooling I am using during these POCs and migration and stuff. So kind of like that.
Okay, well, sounds really interesting. So, guys, just a reminder, we have two chats, one on YouTube, one on our platform, and we collect your questions, comments, reactions, whatever you want to share with us there. And there we monitor both chats. So your questions we will ask in the end of the talk. We really appreciate your participation and your active participation. So thank you very much for being with us here. So I think we can dive right into the talk. So Vadim, good luck, good luck, good luck,
Okay, let's go.
Let's go.
Okay, let's go. One more time, hello everyone, and I'm really happy to attend this such great conference. And during my speech, we will discuss my experience with the migration to JIB and Distroless, along with the advantages and challenges encountered during this process. So before we begin, let me provide you with an overview of the agenda for the discussion. So firstly, I will briefly introduce myself, my experience, domain, and technical stack. After that, I'll introduce the JIB and Distroless concepts. We'll take a look at the problems we are facing on our current project, and moreover, we'll take a look at the storage and network costs, kind of the NDA, but not about the numbers, I believe. So, and the security concerns as well. After that, I will provide you a solution I used to migrate and cost optimize. And then we'll take a look on the results and some insights into the optimization of storage and network costs, time to market improvements, and enhanced security for sure. And finally, we will sum up and gather everything in one bucket, and I'll share my thoughts with you. I believe you could share your thoughts with me also via chat and your questions. So we will delve into each of these topics through the course of my speech. Okay, so let's begin. Who am I? I am a chief software engineer at EPAM Systems with more than 8 years of extensive experience in the IT industry. I'm specializing in domains such as human resources, crowdfunding, and healthcare. Currently, I hold the position of discipline head for advanced software engineering in EPAM, at EPAM in Belarus. And I am a T-shaped professional with a strong foundation in the JVM stack area and related micro frameworks. Aside from my work at EPAM, I'm a passionate performance optimization enthusiast and recognized by Gatlin in 2022. Giving back to the community, I contribute to open source projects, share knowledge as a public speaker, and author articles as a technical writer. During my leisure time, I enjoy hobbies like boxing and reading. Okay, and moving to the next section, introduction. Let's review the JIB and Distroless concepts. JIB, short for Java Image Builder, is a tool that constructs optimized Docker and OCI images for Java applications without requiring a Docker daemon or in-depth understanding of Docker best practices. It's available as plugins for Maven and Gradle, and I will clarify this moment a bit later. Let's take a look at the main benefits of using JIB. Firstly, it's fast. Deploy your changes fast. JIB separates your application into multiple layers and splitting dependencies from classes. Now you don't have to wait for Docker to rebuild your entire Java application. Just deploy the layers that change. That's it. The second, it's reproducible. That means that rebuilding your container image with the same content always generates the same image. Never trigger an unnecessary update again. And the third point is the JIB is dimensionless, reduces your CLI dependencies. Build your Docker image from the plugins in Maven or Gradle and push to any registry of your choice. No more writing Docker lint and calling Docker build, Docker push commands. Okay, let's go to the Distroless. Distroless images contain only your application and its runtime dependencies. They don't contain package managers, shells, or any other programs you would expect to find in a standard Linux distribution. Restricting what is in your runtime container, what's necessary for your app, is the best practice employed by Google and other tech giants that have used containers in production for many years. It improves the signals to noise of scanners, CVE, common vulnerabilities and exposures, and reduces the root cause analysis for different security problems, for instance. Moreover, every Google Distroless image is signed by cosign, and you can easily verify it. Distroless images are very small. In example, the smallest Distroless image is around 2 megabytes. The Distroless Java image contains a minimal Linux and open JDK-based runtime. Who uses Distroless? Kubernetes, Native, and Tecton, and other giants. Okay, I hope that I introduced the JIB and Distroless. Let's take a look at the problems and discuss them. And firstly, I would like to mention, working on my current project, I decided to check our images for vulnerabilities and dive deeper in them. It was a pain for me to find that we are wasting our memory, time, and it's not a cost-effective way. The previous image was constructed using Debian 11, which, according to Docker Hub, contains 256 packages and has been found around 145 vulnerabilities. As an engineer, I decided not to trust a single source of truth and double-check it. The tool of my choice to check the vulnerabilities in JIB, it's a vulnerability scanner for container images and file systems developed by Anchor company. And this company is specialized on the security policies, compliance requirements, best practices, and security in common. So you can find this GitHub repository of JIB following by provided QR code. So reviewing the results, I noted that JIB has identified 515 vulnerabilities and almost 300 packages in it. This contrasts the Docker Hub scan, which reported only 145 vulnerabilities and 256 packages. And take a look. We have 34 critical and 126 high severity problems. Right? Okay, for image in-depth investigation, I use the Dive, a tool for exploring a Docker image, layer contents, and discovering ways to shrink the size of Docker OCI images. It's built on Golang and developed by Alex Goodman, who is a tech lead at Anchor company. Upon examining the image in detail, I observed an image size of 760 megabytes, and there was nearly 100 megabytes of potentially wasted space. At the same moment, I decided to calculate the build time for our images. In my current project, we spent approximately 12 hours per day collectively building images for different environments, which is a significant amount of time and resources. Almost 12 hours for builds per day, or in other words, 36 hours per month, or 2,840 hours or 170 days per year for running our Git runners and paying for them. At this moment, I decided that I have to improve the product delivery, optimize the costs, and manage the risks on the security level. Several years ago, I was wondered to find the JIB and Distroless, and being a knowledge-thirsty person, I decided to give a try these tools and approaches. And JIB and Distroless justified the desire. It was simple for adoption, and no more Docker files. Layers, rethinking of their optimizations, Docker build and Docker push commands again. Delivery pipeline lays on the developers, on the building tool. The single Gradle JIB command on the CI/CD pipeline is replacing a dozen of painful manipulations made by DevOps team. And I took a decision to prepare the POC to compare it with the existing solution. Now I will describe you what kind of steps I passed to migrate it. This is a piece of a Gradle build script in one of our services, and nothing special. Typical setup in most of the projects based on Spring Boot. And there is my incredible changes I added into the plugin section. It was too hard to adopt, but I solved the problem. But unfortunately, this is not the only step. The plugin is flexible. You could choose a base image for your application in the section From, and define the outcome image in section 2. Moreover, this setup contains container properties. You can set up the app root, define the labels, open the ports, creation time, even the JVM properties could be added here. And for sure, to add a non-application related files are available here. So you can find it in extra directories. In our case, it was the APM agent, and it was pretty easy to edit here and set up permissions. But please be careful with it, and review it twice, your permissions and the files you are editing. What about the base images? In case of using Google Distroless images, you can choose the debug or debug non-root images for local development processes or testing, kind of like that. And however, I strongly advise against using them in a production environment due to potential security and stability concerns. Sorry. Yeah, that's nice. And let's compare it with the Docker. And previous solution was using the Docker file that contains instructions to define base images, copying files, install dependencies, and configure the application. It corresponds to each instruction in this file. And the other point, the users need to install Docker runtime on their machine to use the Docker engine for building images. Nowadays, everybody knows about the problem of supporting Docker desktop. So using JIB solves this problem. You could remove it easily, your Docker desktop, and use JIB for building your images in this case. And generally, this solution is slower than JIB as it has to execute each Docker instruction sequentially and commit the result as a new layer. This approach often have a larger size due to extra base layers and additional dependencies. Finally, using the Docker file adds the dependency of Docker linters in the CI/CD, for sure, if you are following the best practices. We'll compare these metrics in the near future. The using of JIB doesn't require Docker file and Docker engine. No need of learning Docker in this case. It directly builds efficient container images for Java applications using its plugins, automatically creates an optimized image, separating the application layers for dependencies, resources, and classes. JIB intelligently caches and reuses layers between builds, making incremental builds incredibly fast. And of course, it optimizes the image by organizing the contents into well-defined layers, resulting in smaller images and faster pull times. Let's highlight the benefits. No need learning Docker. Saves the time on the onboarding new developers, focusing on the business as soon as possible. No any dependencies such as Docker desktop, Docker engine, etc. Incremental builds, it leads to a better time to market metric. Optimized smaller image. Cost optimizes for the storing, transferring, and other processes. Less packages, less potential security issues. I will provide you more details about it. Setup of delivery process migrates to building tool from the DevOps team, as I said before. But it could be mentioned and will be mentioned on the next slide because of not everywhere it could be a benefit due to the fact that migration part of DevOps configuration to the backend part involves DevOps anywhere anyway or someone from the development part. So we discussed the benefits, and it would be nice to highlight the limitations for sure. And firstly, it has limited customization in more complex use cases. For instance, not supported multi-stage builds. It's language specific if we are talking about the packaging applications. And designed for Java projects and Kotlin as well. Yeah. As I mentioned, it would affect pipeline configurations. Not so much in my case, but it could be painful. Ossification setup requires the knowledge of the environment where you are going to deliver the image. The other point of environment, you should understand that the base image fits your environment. Check it twice. If not to dive into details, it works like a magic box. And finally, my favorite one limitation. It's still open. Since JaCoV 21 has been released, we are expecting an updated Distroless image that supports it. However, there are some challenges, such as Distroless images are based on Debian, and JaCoV 21 support on Debian might not be ready available. There is a difference in behavior between non-root and debug non-root images. The debug image contains the JaCoV, whereas the non-debug images doesn't. Concerns about custom trust stores and the different behavior observed with JaCoV 17 and JaCoV 21 Distroless image. And but there are different solutions. For instance, using Thermarin JaCoV, and it's providing separate images with JaCoV and JRE, or having the JaCoV image without these bugs. These approaches are already in testing, and even there are already in Google Cloud Registry, and you can check it. As you can see, the JIB is not a silver bullet, but this approach fits for my project. Let's compare the results. Firstly, let's take a look at the security. Reducing the number of packages in an image can be an effective way to minimize vulnerabilities. In comparison to the previous image, which contained almost 300 packages and almost 500 vulnerabilities, our new image demonstrates significant improvement. With a reduced package count of 139 packages, the vulnerabilities have been brought down to 39, and notably, none of them critical. This highlights the importance of maintaining a smaller package count to ensure enhanced security and stability in our containerized applications. A few number of packages in your image can significantly reduce vulnerabilities. This rule is evident in our new image. In comparison to the previous image with 760 megabytes of size and 94 megabytes of potential wasted space, our new image, which measured at approximately 273 megabytes, is significantly smaller than the previous 760 megabyte solution. Furthermore, the potential wasted space is minimal and is only 600 bytes, not 400 megabytes. This decreases in image size. This decrease in image size not only enhances the performance, but also aids in optimizing storage and transferring costs. Previously, The build process took nearly 12 hours per day, amounting to 236 hours per month, or 2,840 hours. That is equivalent to 170 days in a year. Such extended build times incur considerable costs for Git runner operations. With optimized implementation, we have successfully reduced the annual build time to 1,720 hours per year. And this significant reduction in build hours leads to improved efficiency and considerable cost saving for Git runner operations as well. So we are close to sum up it. Let's compare the costs, and I will share with you my thoughts. Upon comparing costs across various project environments, we have successfully achieved a reduction of up to 60% in expenses associated with transferring, storing, and running these environments. Additionally, we have decreased the build time up to 39%, leading to reduced costs for delivery. This reduction in build time significantly shortened the time to market. Shorter time to market, the awesome metric to penetrate the market as soon as possible. The DTM metric contains development, build, packaging and deployment, and testing time. It sums it. So in terms of development time, if you can faster build your image, it shorts the local development as well. You are not spending a lot of time for these purposes and checking it locally. In terms of building the packaging time, it becomes shorter due to the fact of JIB caching mechanism, and the deployment and delivery processes become shorter due to the savings for transferring and storing shrank images. Lastly, and crucially, we have now reduced the number of security vulnerabilities by 9 times, and resulting in considerable cost savings. Testing becomes shorter in terms of security testing. The exact amount saved due to the improved security is difficult to predict, but it's unquestionably significant. Okay, what to bring into production is up to you. I strongly recommend to review your environments, architecture, delivery strategy, and other crucial moments in your current project. If this approach is working for my project, doesn't mean that it fits everywhere. But for us, it was a significant improvement. 3 times less size, 9 times fewer vulnerabilities, and as a result, less time to test, less time to build and deliver, less time to fix vulnerabilities, less time to deploy and roll back, less time to fix production issues, less money to spend on infrastructure for storing, delivering, and transferring images. And for sure, more time to drink coffee and find new ways to improve our projects and products. Thank you everyone for attending this session. I I'm really happy to be a speaker on the Java conference. Probably you have several questions for me. I am ready to.
Yeah, thank you. Thank you very much for a great talk. Thanks a lot for deep dive in such great topic. So yeah, we have a couple questions. I would like to pass the voice to Evgeny to ask them.
Yeah, thank you so much, Vadzim, for your great talk. So let's start with the first question. Are there anything that might be done via direct Docker file, but might not be done or not so efficient in terms of the JIB plugin?
Sorry, could you please repeat?
Yeah, sure. Are there any kind of the things that might be done via directly a Docker file or in the instructions inside of it, and might not be done with the JIB plugin?
I don't clearly understand you anyway. Your question, could you please rephrase it?
Yeah, generally, so JIB plugin is a kind of the instrument that you use as some kind of the intermediate level between your build system, yeah, like Gradle, and making the final image. And maybe there might be some kind of this efficient ways, yeah, to do like. So you, in your example, you had permissions setting, yeah, for an agent that is running. Maybe something like that in some kind of the options, yeah, that might be done within just shell commands, but JIB is not good fit for such kind of the things. Like network, maybe setting up of the network things, something like that.
Sorry, I probably has interruptions in my. I will put my headphones. Sorry.
Sure. No worries. Do you hear me?
Okay. So, by the way, while we are connecting, while Vadzim is connecting his headphones, guys, just a reminder that we are open to receive your questions in YouTube chat and on the platform chat. Also, I want to say that all the presentations from all our speakers will appear on the platform in the section of the talk. For example, Grace's Grace's talk is presentation already there. So you can find it out, and also we'll request presentations from all our speakers and put them on the platform. So now coming back to the question, Vadzim, can you hear as well?
Yeah, I hear well.
Yeah, that's great. So let me repeat it one more time. Yeah, with a paraphrased option. Yeah. So in one of the parts of your talk, you showed that there is an option, for example, to set the permissions. Yeah, to the things for the final image that is built and so on. Are there any kind of the things that will be more convenient to set up with a Docker file directly than to use JIB plugin and its internal configuration elements for doing some kind of such configuration elements? JIB, yeah.
That was confused me because of you saying a JIB, and for me it's JIB, and I don't understand what is it JIB.
I just made it shortened. Yeah. No.
Okay, so if you're talking about the moment where I've added the APM agent, if I understand correctly, and set up for permission for it, the other way to add it using JIB, there is no any point. So, but when you're using Docker file, you could add any copying for any directories. So if you are proficient with the Docker, you could easily set up it. In terms of JIB, you could use extra directories and add these in this section everything you wish. But to be honest, for the latest 3 years of using JIB, this is the first time I had to add something on the extra directories, and it was the APM agent for telemetry.
Okay, yeah, sounds good. Another question is coming that is related to the base image. Yeah, so one of our listeners is asking about considering such image as Alpine Linux Docker image before migration to the JIB as a final solution.
Yeah, for sure. I tried, and before the Distroless, it's a bit confused because of do not mistaken, don't be mistaken in terms of JIB and Distroless image. JIB is a Java image builder. It's just a set of rules and presets that are helping to build your Docker image without Docker engine. And in terms, we are talking about talking in terms of the base image, kind of the Alpine images could be checked for the vulnerabilities. You can find that it has packages and shells. You can detect them as well, and they are less secured in comparing with Distroless, for instance. But as you saw, as you can find the limitations I listed before, this approach could be painful as well. So be careful. But it could be helpful like a gun, but do not shut your legs.
Okay. I guess the last question from my side, so that is coming. You mentioned that Java 21 doesn't support it, right now, and is not adopted to JIB plugin. I mean, so the usage of JIB plugin on top of the
already is adopted.
Okay, so it is closed, right?
But bug is opened. This bug is related to Debian. And Trixie, Debian, 13 version of Debian Trixie now will be released in 2025. And still the JDK is not ready. There are no any support of Debian JDK 21, but Eclipse team provided the Xamarin. And if you will go through the issue that I pointed presentation, you will find that it works. Sometimes it could be painful with certificates. You have to copy it during your building time. They appear time to time. These problems appear from time to time. It's not clear for me what to do in the future, but my day started from grabbing a mug of coffee and checking what is going on here.
Yep.
Okay.
I think that.
I
think that was the last question.
Okay, great. So
you can ask me whatever you want.
About your hobbies, maybe. So guys, I think you can find you can find Vadzim still in chat and YouTube. You can post your questions. Thank you, Vadzim, very much for your great talk, for great topic. We were glad to host you on our conference and glad to have you. Thank you very much.
Thank you, everyone, that you asked me to attend, and it was one more incredible experience. And I hope we will see you in 2024, the Java conference. Maybe offline.
Hope to
maybe
see you as
offline.
Well. like this. Okay. Thank you very much. Thank you very much. I think we say goodbye to you. And this is nearly wrap up of our day one. So thank you very much, guys, for being with us. Before we wrap it up fully, I want to remind you, of course, that tomorrow we have 3 great talks from Alexander, Peter, and Evgeny. Tomorrow will be more focused on AI, on ChatGPT, and everything related to that. So don't miss it. I hope it will be really great if you want to find some real examples. And Friday, day number 3 of our conference, we have 4 great talks, mostly about frameworks. And Josh Long will finish our conference with great talk about Spring Boot 3. And just in like 8 days, Spring Boot 3.2 is releasing. So I hope Josh will share some thoughts about that. Another one reminder that we have online activities with making a photo of how you're watching the conference and get a prize, and 2 great quizzes. Take part. It's fun and just like some activities, not only just watching speakers, right? And also we have offline activities in some locations, so search them on our page, and if you're there, you may join. So Evgeny, what do you think about day one? Do you like it?
Totally, yeah. It was totally amazing, and I'm totally sure that next days, yeah, will be the same with the same seniority level, with the same experts level, and they will be covered with a so professional team of us. So if nobody will say thank you for us, then we will say. So,
Yeah, for sure.
yeah. So
Yeah, so
yeah, generally speaking, it was great day, and even other days will be better and better in different terms. But today, I guess we're done.
Yeah, we're done. So I want to thank Evgeny very much for being co-host today with me. It's a huge pleasure for me to make this event with you. So thank you very much for spending your time with us and for moderating this talk. Thank you very much.
Thank you so much, Romo, for inviting me here.
So yeah, that's end of day one. Thank you guys very much for being with us through all this time. I've just checked the statistics, but we have nearly 1,000 attendees for day one. Wow, that's huge. That's huge. I really like that. Hope tomorrow we will just grow these numbers. So thank you very much again. See you tomorrow, same time we're starting as we started today. You may find all schedules on the platform and links in the description. Subscribe on us, click like button, and click notification button not to miss our stream tomorrow and on Friday. Thank you very much again. Have a good rest of the day. See you. Bye bye.